Again, thanks everyone for joining. And my name is Adam. Now, ideally, when we are working as a DevOps engineer, one of the common tasks that you would get, or one of the important automation that we have to help an organization or a product is setting up CI/CD pipelines, right? And that's also going to be one of the common question that anyone would ask you in the interview. So, being that. This session would be mainly focusing on what exactly is the CI/CD pipeline, and in terms of security, how do you implement the DevSecOps into the CI/CD? Okay, so that way, let's deep dive into the concepts about what's exactly CI, what's CD, and how do we add the security, which is the DevSecOps, towards it. Okay. So to get started, let's kind of first understand in a general workflow in any organization. So what happens first, developer writes a code and that would be given to QA where they do different kind of testing. And once QA certifies the product, we deploy that application into a environment called staging environment. And this is where we test based out of how the customer would access, which is what we call it as the user acceptance testing. And once this is done, then we put our product into a environment called production. And this is where customers will access. However, with the market moving very faster, so what exactly we need is a continuous delivery of your product. Whether you take Facebook, LinkedIn, or any banking site, or your shopping website, or any e-commerce site. So we need the delivery of the products continuously on our web page, right? So for this, what we have to understand is almost everyone in the organization has to continuously work, which means for delivering a product continuously, the work starts with the developer, where continuously with whatever the requirement they get, developers have to write the code or the program. And then equally, that code has to be tested continuously by QA. And whatever the code that has been certified by QA, we need to continuously put it or deploy it into staging or production environment. And that's exactly what the customers will be accessing. So this process where the developers continuously work, followed by QA continuously taking that and testing, and then the code which QA has certified, we continuously deploy it into production so that customers can access. Now, this is exactly what we call it as continuous delivery. Now, however, if you look closely, so continuous delivery is a practice, which is when whatever the code which developers continuously modify depending on the requirement, we test it and we make sure that code is ready for production. And eventually, your entire continuous delivery process can be divided into two categories. So that is CI and CD. So the automation or the work which we continuously do to integrate the development and the testing is what we call it as CI, or continuous integration. And at the same time, the code that has been certified by QA, how do we make sure that it is put into the staging or production environment so that the customers can access is what we call it as continuous deployment. So basically, when I say CI/CD, CI/CD is the process which helps us to implement continuous delivery, so that right from the beginning, how a developer modifies the code, you take it and hand it over to QA, and QA can test it, and once the QA tests it, we put it into production, right? So this is when, for us, implementing continuous delivery is where we kind of implement your CI/CD. So CI/CD is needed because every company is focusing towards continuous delivery. So let's be clear on that first, on why exactly do we need CI/CD. But still, if we take one more step, So most of the time when you go out and see any of your YouTube videos or any Google, right, notes, usually when we say CI/CD, it's not a single stretch of automation where we build a test and put it into production. So you have to divide, or ideally, it is divided into two parts of automation, especially when we are trying to automate. As I was showing in the previous slide, we need to automate it into two halves. So the one half is automating the build, which is where as soon as a developer completes his work, how do we take that code, convert it into a product, and how do we give it to QA, right? And at the same time, when I have a product, how do I make sure whether if I want to deploy it on a QA environment or on a staging environment or a production environment, I need to have the ability. So that's when your CI CD is ideally not a single stretch of automation, but it is kind of divided into two parts. One is the build pipeline and the deployment pipeline. And that's where when we are adding security and also automating this end-to-end CI CD, it is important for us to understand each part separately and then how both of them are connected to form end-to-end pipeline, which is what we call it as CI/CD. All right. So now let's get into each part one by one. So first, let's understand how do we automate and secure your build pipeline, and then we'll understand how do we automate and secure your deployment pipeline, and in the DevSecOps, how do we connect these two to form your end-to-end CI/CD pipeline. All right. So now, as most of you understand, so when I say a build is a process where you take a program or a source code of a program and you convert it into a product or an artifact which can be consumed by QA or customer. But in a traditional method, what happens is, well, now assume you have a bunch of developers where we store all our code into a server like GitLab or GitHub. Now, eventually, when a developer modifies the code on his local workspace or on his workstation, he or she will do a unit test, followed by, if that is fine, then they will go ahead and commit and push the code from their local repo to remote repository. The same way, every developer will go through this process. But what happens is, when we want QA to test, so usually we wait for some time to accumulate all the changes which different developers have done, and then we take the code at some point of time in a day and we go ahead and do a build. Now this way of building is what we generally call it as nightly builds. Okay, so this is one of the traditional method which we were following. Now what happens in this method, once in a while, so let's assume once in 5 hours or 6 hours, you do a build, and if that build is success, we give it to QA. But what happens if a build fails? Now, why would a build fail? Because there could be a problem in any one of the developer's code, or the developer has modified and he has tested his code, which is called as unit testing. But when multiple codes are combining, sometimes that might not work. And that's exactly when what happens is, when we do a build, and if the build fails for any reason, then the problem that we have is we need to ask QA to wait, because we don't have a successful build and we don't have a product or an artifact created. So QA has to wait. Now, if QA waits, what will happen? Your continuous testing is not happening, right? If QA doesn't complete the testing, you will not be even going to the next step, which is called a CD or continuous deployment. So this is one of the problem. The next problem is, okay, we need to ask developers to fix the code. Now, for a developer to fix the code, which developer you will ask? Because in a matter of 5 to 6 hours, there might be 10 or 15 commit IDs, and there might be multiple developers who would have modified the code. So which developer you will go and ask? And that's exactly when it takes a lot of time for us to debug and find out which is the exact code which is having the problem. Now, overall, when we follow this traditional method, what happens is we take a lot of time to identify the problem or a bug, and at the same time QA has to wait, and this will cause our continuous delivery to be interrupted, or in other words, you will not be having continuous delivery. Your release will be delayed. And this is when our interest is to overcome these issues and to enable continuous delivery, which means as soon as the developer completes his work, we should be in a position to test it. Okay? Or if there is an issue, we should be able to immediately tell the developer that your code has a problem, please fix it as soon as possible. And this is where the market came up with a new process of automating the build or the build pipeline, which is what we call it as continuous integration. Okay, so let's first understand that. So what is CI, or continuous integration? So it's a process in which instead of waiting for some time, as soon as a developer modifies his code and pushes it to the remote or the central repository, we immediately build it. And we check whether we can give that build to the QA, or if there is an issue and build fails, ask the developer to immediately fix. And if you try to see how it works, so the same way, now when a developer modifies the code, immediately we do a build. Okay, and when this build is success, we give it to QA, and if it fails, we go back and immediately tell the developer that, hey, your code which you modified is not working fine. That could be for a unit test it is not working, or while the code got integrated with other code, it might not be working. For whatever reason, if the build fails, immediately we go back and tell the developer. So this way, as soon as a developer modifies the code, we will have the ability to create a product or do the build and tell if the build is success, I can give it to QA. So this ensures there is a continuous development, because what is continuous development? It is not that developer will just write code and throw it off. Well, the code that he has given should not have any problem. If it has problem, he should take it and immediately fix and once again give it back. That's what we call it as continuous development. So in this method, developers will be able to continuously develop, and they will know in case if there is a problem, you can find it out immediately. So continuous integration is a process in which the developers will be able to find out if there is a problem immediately, because as soon as the developer modifies the code and pushes the code to the remote repository, immediately we do the build and we tell if it is failing, who is causing the problem. And the same way, now, since if one developer pushed the code and if it is not working fine, immediately there will be one more developer who is modifying the code, and if his code is successfully built, QA can take it and go ahead to the testing. So that way they don't have to wait. Correct? So the earlier problem, whichever was introduced by a developer one, he will be fixing the code, whereas the second developer whose code is working fine, we can go ahead and further do the testing. So that way continuous development will be happening, continuous testing will be happening, and the same thing can be delivered. So you will be able to reach faster releases. And in other words, continuous integration helps us to drive the continuous delivery process. Okay, and not only that, it helps us to improve the quality, because instead of accumulating all the code and doing testing in one go, as soon as you get a code, if you are able to test it immediately, if there is any bugs, we will be able to find and fix it. So that way, with the help of continuous integration, you will be able to do faster releases and the quality of your application or product would be very high. Okay, and not only that, in continuous delivery, CI is your most important and the first part which enables us to drive. So that way, let's first understand now, if you are going to set up your CI/CD pipeline, the first pipeline that you have to set up is automating the build, in which whenever a developer pushes a code to a particular repository, you should be able to immediately trigger a build and tell the developer whether it is good or it is not good. All right. So now let us get into the pipeline stages. Okay. And ideally, well, we are not just focusing about a regular CI build or a regular build pipeline, but we need to implement a security towards it. So that is where applying security on top of anything becomes DevSecOps. Okay. So now our focus is how do we automate a CI or a build pipeline, and in that we are trying to see how do we ensure more and more security can be implemented, and that's where in a real time, okay, there are close to 9 stages which we have to think about implementing to make it a successful DevSecOps build pipeline. Okay. But other than that, in general, if you understand, it's just a build pipeline. If I trigger this pipeline for every commit or every time a developer pushes the code, then this build pipeline is called as continuous integration build pipeline. Okay. Why I'm saying this word? It's not always necessary that every time a developer checks in the code, you need to trigger, because logically, it's not possible to make it that much. Why? Let's go to a company where you have hundreds of developers, and in the same time, you will be having 5 to 6 commit IDs pushed. So you didn't think at the same time you will be able to trigger 5 builds? No. So logically, it depends on the organization. There might be some gap, but continuous integration is more the ability which we need to introduce in the automation in such a way, if a developer wants, they can enable a pipeline automation in such a way as soon as they commit or push the code to a remote repository, a pipeline should get triggered. But if not, DevSecOps is for the entire pipeline. So what are these 9 stages which we need to follow as of now in the market, which is what is expected? Okay. So let's take step by step. And first, let's understand what are these stages, and we will see how do we implement and automate. All right. So now, any build pipeline that you take, the default stage will be to check out the code from a particular repository. And in that also, you need to check out the code of a particular branch, correct? Because whether you're setting up this build pipeline for a feature branch or an integration branch, it's up to the team. But ideally, the very first default stage will be when you run the pipeline, you need to check out to the right repository and the correct branch that you want. Okay. Then what do we do as the actual first stage is build and unit test. Okay. So what is the purpose of build and unit test? So you convert your raw code or source code into a product or a deliverable, right? And this pipeline stages remains the same or common for almost any type of programming language or any application that you take. So for example, let's say you have a Java based application. So your build stage will make sure you generate a jar or a var file. Same way, if you have any other programming languages, probably you might get a zip file or a tar file as the artifact. So that way, the first stage focuses on converting your source code into a product or an artifact which can be consumed. And at the same time, we also go ahead and do the unit test. Now, there might be a question at this point like, why do we want to do the unit test? Because in the first slide, I was trying to tell, developer also does a unit test and pushes the code. So why do we want to do it here? Now, this is where, even though we call it as unit test, the difference is we are going to take all the code that is there in the repo, and we will be doing the unit test of all of them individually. So that way, you can call it as an integrated test, not an integration test, but you are doing unit test of multiple code which are integrated together. Whereas what does the developer does before he commits the code? He will be doing a unit test of only 1 or 2 files. For example, if it's a Java project, then he or she will be testing 1 or 2 Java files which they have modified, and they will push that code. Whereas in the build, we take all the code that is there at that point of time, and we run the unit test against all of that code. So that's the difference. So it is still unit test, but we do unit test of almost all the codes that is available. Now for this, depending on the programming languages, there are different tools that are available. Right now, in our example, I'll be just taking up a Java based application or a Spring Boot application, so for which one of the popular tool that we would be using is a tool called Maven. So the first stage will be to build and to unit test your code. Okay, now once that is done, the next step or the next stage in DevSecOps is called as code coverage. Okay, what is code coverage? Now, most of the time, the name itself will give you an answer. What is code coverage? Well, to understand it, now let's take this question. In the first step, after the build, we ran some unit test. Okay, so pay attention. Now, let's say there was 4 test cases which we executed in the build stage. Now all the 4 is success. Now, can we guarantee that the product is good, or whether have we really tested the entire product together? Now that might be confusing again. So let me be more clear. Let's say when we do a build, there was 10 files and each file had 100 lines in it, just assumption. So overall I have 1000 lines. So now when you did a unit test after the build, and let's say you executed 4 test cases and all the 4 test cases are passed, but can we tell whether that 4 test cases has really covered all those 1000 lines? We cannot tell, or we don't really know. Correct? How? Again, just an example I'll tell you. Take your mobile phone. I'm telling you, okay, I will give you 4 test cases and tell me whether this mobile is good or not. What are those 4 test cases? So I will just tell you, first switch on the mobile and check whether login screen is working fine. Second test case, I will say switch off your phone and see whether it is shutting down properly. And third thing I will say, make a call to some number and check whether you're able to do the call. Okay. And fourth thing I will say is connect to Wi-Fi and then check whether internet is working. Well, these are the 4 test cases. Now, can you guarantee me with this 4 test cases, is this phone good? We cannot. Why? Because you have used this phone, so you know very well it has lot of other applications, there is lot of other functionalities, right? So for 4 test cases, you have tested something, but you cannot guarantee that this 4 test cases is sufficient to test this entire mobile. The same way, when in the first build stage, we ran 4 test cases. When the 4 test cases is success, we cannot guarantee that it is sufficient. So that is when what we need is a step where we need to check how many lines of code we have in our product, and the test whatever we have run, unit test, how many lines has it really completed? And that step is what we call it as code coverage. Okay. So usually when we run code coverage, we get the result in some percentage. So now let's say you had the same 10 files with 1000 lines and you are getting the code coverage as 60%. So what do you mean? That means by running those 4 test cases, what you have really covered is around 600 lines, and still 400 lines has not been covered. So this is how, from the result of code coverage, we will be able to find out whether do we need more test cases to ensure that whatever the remaining code which has not been tested will be covered. Because when the coverage of the code is more through your test, or when you do more test, you can always ensure your quality of the product will also be higher. So that way, code coverage will help us to find out whether we need more unit tests to be done. But at the same time, it can also tell you whether the code which has not been tested, is it really needed or is it some unnecessary code or a junk code which the developer has put? Just like a mobile, I know that the basic functionality of the mobile, but you install some unnecessary apps in it. Does it really need that you have to test all those apps? Because I don't need that functionality. The same way, when a developer writes a code, it is not that whatever he writes we should be able to test. We can also guarantee that, okay, now I have run some test cases and I'm sure that these are the only test cases needed for my product. Then why is it code coverage still showing that there is some percentage not covered? So that will help us to find out if we need more tests to be done, or if the code is a unnecessary code or an unused code which is something we can remove. So by doing this, what will happen? You will ensure quality of the product will be good and performance of your product will be good. And this is where in DevSecOps, we need to run code coverage after the build. And why should you do the code coverage after the build? Because when you do the build, you also do the unit test. And for code coverage, unit test is the input. Got it? So that's how you first do the build and unit test, and then you do the code coverage. Okay. Now, again, there are many tools preferably available in the market, open source and enterprise, but depending on what programming language that you are using to build, and for that, there are some specific tools. Now, one of the example that what I'll be using and one of the most popular tool in the market for code coverage is Jacaco. So we will see in the automation, once you do the build and unit test, how do we use a tool or a plugin called Jacaco and find out how much of code has been really covered by your unit test, and decide whether we need more unit test to be done, or is there any unnecessary code which we can remove to improve the performance. All right. Now, once you complete your code coverage, the third stage what we will be going into is called as static analysis, or we also call it as software composition analysis. Okay, SCA. So what does SCA mean? So now developer has written a code, but many times what happen, we don't write the code from scratch. We might be copy pasting from some place in internet or from some other blocks. Now this is where every application, we need to make sure that we don't have any dependency of some third party application, or we are not adding any open source code into our product. Because if you are taking a code which is already licensed as open source, and if you add it to your product and you sell your product, then it is going to be a issue. So that is where it is mandatory for us to find out whether developers have used some kind of open source code which could cause some license issue, or which could cause some vulnerabilities, because we don't know, right? You're taking an open source, definitely there could be a lot of issues. And not only that, does it have any other dependency code which is not being owned by the company? So that way your SCA step helps us to find out those kind of code, and we will be able to tell whether these kind of code has to be removed. Okay. So we also call it a static analysis because you can do this step even before the build, or you can do it in parallel with the build. As such, there is no hard-coded rule saying that you should be doing it as a third stage, but it's just a best practice. What we always do is, once we do the code coverage, we go ahead and do the static analysis. But either way, remember, you can do the static analysis first and then you can do the build also, not a problem. Because for the SCA, you don't need to do the build. You just need the raw code. That means you have the Java code or the JavaScript or Node.js or Python code. You can just take the raw code and you can do the analysis. But anyway, just remember, this is going to be one of the stage. And again, there are plenty of tools available in the market, but I prefer to take an open source tool, which is given by a community called OWASP. So first of all, you have to understand what is OWASP. Like how for different applications, different rules. So for web application security, there is a community or a group called as OWASP. Okay. Now they give us a lot of rules and tools using which we can make sure that if my application developed is a web application, I can secure it. So in that way, dependency check is a tool using which you can ensure whether your source code, that is whether your Java code or a Node code, has any vulnerability because of a third party application or a open source code. All right. So this is how now you're not only telling your product you can build the code, but you're also finding out how much of the code coverage and does your code has any open source vulnerability or a third party dependency. Clear? Okay. Now, once you finish it, the next stage, which is important for us in the DevSecOps, is SAST. What is SAST? So SAST stands for Static Application Security Testing. Once again, it is static. So the meaning of static means you don't have to run your application, but we need to build the application. So far what we have done, we build the application and we have checked the code. But this time you will take your actual application, but you don't have to run it. Okay. Now this is a mistake because sometime without knowing, if you tell for SAST you run the application, that's very clear you haven't done. So for SAST, you don't have to run the application, but you need the application. Now what we will do in this is we will scan the application and we will try to find out whether our actual code has any vulnerabilities. Okay. Because this is where so far all we checked is whether our code has been really covered in the test case and whether our code has a open source vulnerability or third party dependency. But this is where we actually check our actual proprietary code. Is it vulnerable? Okay. So is it hackable, or does it have anything like a memory leak? Or another important thing which you will do in the SAST scanning is, have you followed the coding practice? Because anything we buy, there is a certificate. For example, you are buying some product, especially I'm talking in India. Do you know that there is something called as an ISO standard? So you can guarantee yourself that, okay, I buy a product and if there is a ISO standard, then they have followed some protocol and I can guarantee it's of good quality. The same way, every application a company goes through has to follow some standards. Okay. And this changes from country to country. So that is where sometimes a product generated in or developed in one country will not be accepted in another country because they don't follow some protocols or best practices. And that way, now when you are developing your code based on the company, we need to set up some policies and say whether have the developer followed that practice and is the code within the same standard that you have followed. So how do you make sure? Because we are not talking about one line or two line. Just the example in the beginning, I said you have 10 files with 1,000 lines. Now what if in real time I tell you your application will have 1,000 files and million lines of code? So it's not possible for us to sit and check whether every line of code is following a best practice. And that's exactly what we do in the SAST. Okay. So what is the purpose of SAST? To find out whether your code has any vulnerability in the web, and at the same time, have you followed the coding standard to make sure your code is secure? So that way, the SAST will give us those results. And usually what happens when we get a result in SAST, right? If there is a vulnerability means issue. So usually we categorize into critical or high or medium or low. So as the name says, low means, well, it's not going to cause any impact. Medium means there are some small impacts that can happen. High means definitely it is going to cause some problem. Critical vulnerability means if you put it, definitely nothing will work or it is completely hackable. So that's where, depending on the vulnerability type, you will also get a result saying how many vulnerabilities are there in your code and what is the category, whether it is critical, high, or low. At the same time, how many lines of code has the policies not adhering, or it has some coding issue. So it will also tell us. All right. Now, what are the tools that you can use for that? Now, again, there are many tools in the market, but one of the popular tool which I personally like is SonarQube. Now, people use SonarQube without knowing why they are using it. Now, SonarQube is an open source as well as an enterprise tool, and it acts as a SAST scanner. So, using SonarQube, you can do a scanning for the SAST results of your application. And why SonarQube preferably, if you ask me? It can help you to do the scanning against various programming languages. So not just one tool. Okay. So that's where one of the most widely and preferable tool for SAST is SonarQube Scanner. So using which you will be able to find out how much of vulnerabilities and what is the type of vulnerability that you will be having in your code. All right. So by this step, what is that we have done? If you just recall quickly, we do a build, we run the unit test, and after that, we do the code coverage and we generate some percentage. We do the static analysis, that is SCA, and we generate some scanned result. And we also do SAST and we generate some scanned result. What is the next step we have to do? So now you understand these are the steps which are we are going to automate it as part of our pipeline. So we are not just trying to run one by one manually. Everything is automated. That's why we call it as pipeline. So now in a company, if you are following DevSecOps, so the next thing what you have to do is what is the standard that you follow in the company, which will tell whether a code is good code or not. That is whether the code is quality or not. Okay. And that, how do you check? Because you will now get a result of code coverage, you will get the result of SCA and SAST. Now combining all the three, we need to put some kind of rules which will tell, for example, if my code coverage is above 80%, then only I will say your code is good. If I get a vulnerability list, if the vulnerability is not above medium or high, only then I will say your code is good. Or if I say the number of lines has coding issue is less than, let's say, 100 lines, then I will say your code is good. So this way we need to set up what we call it as a standard. And only when the results what we have got out of these three steps, that is code coverage, SCA, and SAST, is within the results of our standard, then I will follow, or we should be immediately telling your code is not good code. And how do we do it automatically? And that is when the fifth stage of our DevSecOps pipeline in the build is quality gate. As the name says, gate for a quality. So it is like code has come through this fourth step. In the fifth stage, what we are telling, I will put a standard. If all the results from this is okay for me, only then I will allow the code to go through my gate. If not, we will block. Okay, so that is how you're putting a gate for your quality. So what is quality gate? It's just a standard stage in which you check all the code what you have written and take the results of all the three stages and check whether it is within your standards what you want. So that is when for every company they will have their own standards. Like an example I said, I can say in my company code coverage will be not less than 90%, which means code coverage definitely has to be more than 90%. Vulnerabilities should not be greater than high, and I can say the number of duplicate lines should not be greater than 100. So assume this is my standard. So if my code doesn't match this, it is equivalent of saying your code is not good for testing. So immediately we should stop our pipeline and indicate it to the developer or notify to the developer. Why? Because what is the point of implementing DevSecOps? is not just to tell that I will build and give it to QA. If there is an issue, continuously tell the developer that there is a problem, because you understand the output of a build pipeline is not just a product, but whether the product is of a good quality and can I really test it. That is what is the intention of your continuous integration build. So this way, what do we do is we run the quality gate, and if the quality gate fails, we tell the developer to fix the code. And if the quality gate passes, then we will say, okay, let's go to the next stage. Now, how do we achieve it? Now, this is where the SonarQube tool that I was telling you earlier basically has two uses. So SonarQube has something called a scanner, which can help us to do the SAST scanning against our application, as well as SonarQube is a web application. So it has a dashboard in which we can store all the three results of code coverage, SEA, and SAST, and we can also do our quality gate check whether what is my standard and whether all the three results has been passing it or not. So that way, we will see in the automation a little later, your SonarQube also has a dashboard in which we can collect all the three results and we can do a quality gate check. Okay, so that way, once again, we will be using SonarQube for this. So what we will do in our pipeline is we will run the individual code coverage, SEA, and SAST. We will store all of that into a SonarQube web page or a SonarQube dashboard, and then we run the quality gates against it and check whether we are meeting our standards. All right. So now, if your code has passed the quality gates standard, then we go ahead with the next stage. So what's the next stage? Now, this is where we are talking about modern deployment. So now, instead of traditionally taking your application, going to a machine, installing and running, the modern way of running your application is through containers. Okay, and for that you might use Docker or you might use Kubernetes. But before that, if you want your application to be deployed as a container, then what you need to do is generate a image out of it. Okay, and this is what we call it as a deployable artifact. So your pipeline output will be a deployable artifact, which is a Docker image, and that I can put it into OpenShift or into Kubernetes, and I can create a container which is nothing but deploying my application. So that's when in DevSecOps, only when your code has passed the quality gate, you will go ahead and generate a Docker image. And eventually for this, you will have to develop a Docker file and you run the Docker build command with the help of a Docker daemon. Okay, this way, once you generate a Docker image, what is the next thing you are going to do? And in DevSecOps, now, by doing SAST or SEA or code coverage, you are guaranteeing your source code, your application that you built is good. Okay, but now when you come to the build image step, what do we do? Now this is where whenever we say building the image, it is basically you take a base image which will contain some OS plus some dependent application, and on top of that we add our application, right? So that's where in the Docker image, you will have a OS layer, we will have a dependency layer, and you will also have an application layer. So far, all you have done is the application or the application layer. But now, what is that QA or what is that we are going to run in production will be a Docker image converted into a container. So that way, we also need to certify what are the different layers available in your Docker image, whether it has a vulnerability or not. So that is when we need to do a scanning of your image so that the image along with your application, what and all the other files or layers or operating system it is there, does it have any vulnerability? We can also find out. Because just by saying, okay, I generated a jar file or a zip file of my application, that is good. But I have put inside an image and that image has some issue, or the image has a OS which is vulnerable, then obviously your production environment will be vulnerable. And that's when what we have to do is, along with your application, what we are delivering it to QA or customer is a Docker image. So we also have to scan your Docker image for vulnerabilities. Clear? So that way, the seventh stage is about scanning all the layers of the image to find out if there are any other vulnerabilities apart from your application. And once again, there are plenty of tools available. Well, for the sake of our automation, we can take Trivi as one of the common tool, and which is much more simple and lightweight that you can practice. All right. Okay. So what is that we have done? So you so far ensured your application is secure. It doesn't have any vulnerability. You're able to build a Docker image, which is what we call it as the deployable artifact, and that is also secured. But in DevSecOps, there is another basic, which I say it as a common sense is, okay, you scanned, there is no issue. Can I just go and give it to QA? No. Why? Because it's again, what if you ran the build, you ran the image generation, what if you have done some mistake in the Docker file? Something is not added properly. Well, your image generation is success. Your scanning is also saying no issue, but your image build is not proper. And this is where in DevSecOps, in your build pipeline, one of the last stage, what you have to do is test your image. Okay. And technically we call it as smoke test. So smoke test means it's just quickly to check whether it is usable or not. Well, an example I can tell you. So assume there is a car which is being generated or manufactured. Now, before they send it to showroom, they just assemble all the parts, right? They just have to do one basic testing, like put the petrol or gas and switch on and see whether the engine is starting, whether all the basic electric system is just starting. They are not going to do a test drive and check just whether ignition is working or not, right? Because what will happen, think on this way. They assembled everything, but by mistake they didn't assemble properly, or some nut and bolt is loose or very tight, or some spark plug or some electric connection is not there. What will happen when you go and send it to the showroom? Someone will see at that time, they switch on, nothing will work, they say your car is not proper, right? So exactly the same way, well, you generate or you build your Docker image. Before handing it over to QA, we need to quickly create a container from it and check whether I am able to create a container, which means the image what I have generated is proper. Okay, so that simple test to ensure that the image is proper is what we call it as smoke test. And only when your smoke test is complete, what do you certify? So now we certify that, okay, the code what developer has modified, it doesn't have any of the vulnerabilities, and we are able to successfully build a Docker image which can be deployed by QA or which can be used by customer. And at the same time, it is ready for your testing and for the next step. And that's how we create a basic container out of your image. Got it? So only when your smoke test is completed, now we send a notification and we go back and tell to the QA that QA, now I have a Docker image which contains a jar file or an application which has a code modified by developer, and please go ahead with your testing. And that's how continuous integration is about running these stages, which will take the code from the developer and give it to QA for the testing. Clear? So I'll again repeat. So what's the output of your CI build pipeline? Is a Docker image which certifies your application is ready for testing and that application doesn't have any vulnerability. So that's how we mark continuous development is done. because in any one of the stages, if there is issue, we should stop the pipeline or the automation and send the notification to the developer and say there is some issue, which could be a code coverage issue or a vulnerability issue or a third party dependency issue or the image generation, it is not working fine. So that way, either any one of the step is not working, then it's equivalent to saying that your application is not ready for testing or your application has a issue with the quality. All right, cool. So now let's go ahead and see how do we actually implement our first part of our DevSecOps pipeline, which is this CI build pipeline. Okay. Okay. So now all the code is already available in GitLab and it's been made as a public repo. So you can always go ahead and clone and start working. Not only this, all my previous projects are also there. Now, if you log into gitlab.com/learn DevOps easy, and in that, I want you to go inside DevSecOps. Okay. Now, in this, we are first focusing about Spring Boot build pipeline. Okay. Now, I have a sample Spring Boot code in it, which we will try to build and we will try to generate Docker image and also deploy. That's for the next stage. Now, the first thing what you have to do is, how are you going to automate this? And this is when a tool like Jenkins comes into the picture. Okay. So as a prerequisite, what you have to do is make sure that you have a Jenkins server, and with the help of that, we will be able to automate this entire build and deployment pipeline. But first, for the build pipeline, what and all you need? So you need to have one Jenkins master, plus I need to do all this build and I need to generate this Docker image, as well as you need to do the smoke test. So eventually you need one build machine. Okay, so you need one machine to run your build, run your unit test, run your all the SAST, SCA, Docker image, and your smoke test, all of them. And I also need another machine to install and set up SonarQube. Okay. Now, if you are familiar with SonarQube, which is available in cloud, you can take it. But again, for this session, I'm just trying to take three machines. One for your Jenkins master, one to act as a build machine, and one for your SonarQube to run. All right. Now, this is when you can think of using Terraform. Okay. Now, that's where, see, the focus for this session is more towards the pipeline. So that's the reason I'm not trying to put in any other fancy things just to cover up. But ideally, anything that you create in your infra or on your cloud like AWS, think of using Terraform. Okay. But however, I'll go ahead and quickly create two machines because I already have a Jenkins master. So just to save time, I have a machine already created in which Jenkins is installed. So I'll go ahead and create two new machines. All right. And I'll just call it as build server. And we'll take two machines. I'll rename it and we'll take Ubuntu. And this is when I need a little larger machine. You can try with T2 Micro, but I would suggest you to take a little larger machine for this practicing so that everything will be faster. And also, SonarQube is a little larger tool. So what we will do, I'll take two T2 medium machine in which I'm going to get 2 CPU and 4 GB RAM, and go ahead and give a key pair for that and the default network. And again, preferably have around 15 GB to 20 GB, because when you do so many builds and unit test and you're trying to run a lot of DevSecOps tools, it will take some memory and space. So ensure that you also have a good amount of storage and memory on the machine. All right. So let's go ahead and launch. So meantime, when it comes, we'll just go ahead. Okay, all these machines came. So what I'll do, I'll rename one of the machine to SonarQube, so that you will be clear. So one Jenkins master, one build machine, and one SonarQube. All right. So what's the next thing you're going to do? Now, since we are using Jenkins, we need to make sure that there are some plugins that we are going to use. So let me first give you those details. So if you come down, I've already listed. So we need to make sure that in our Jenkins, we have these plugins already installed. What are those? So ideally, when you install Jenkins, you will get a suggested plugin. So Git and JDK will be there. But I want you to install a plugin called parameterized trigger plugin. I mean, we don't need Ansible for now. I want you to install GitLab plugin. Okay. And again, we don't need Artifactory, but what we need is a Docker pipeline, because we are going to automate the image generation, and we need a pipeline for Amazon ECR, because that is the location where we are going to push our images. Okay, but optionally, if you want, we can also put it into Docker Hub. So that's completely up to us. So whether I can take ACR or Docker Hub. So what I'll do, probably, let me change this and tell you what we can do right now. So I don't need all of them. So this should be good for us. So go ahead and make sure you have parameterized trigger plugin and GitLab plugin, because our source code is going to be in GitLab, and then Docker pipeline and pipeline AWS steps, followed by SonarQube scanner and Quality Gates plugin. So these are all the plugins that we need to make sure that it is already installed in our Jenkins. Now, I'll just update this code so that you can refer that later. So once you have your Jenkins up and running, just log in. And again, for the sake of reducing the time, I have already pre-installed this plugin, but still what you guys can do is go ahead and make sure if this plugin is not installed, install it. But let me show you what are those plugins. So I don't have anything here. It's a new Jenkins. Now go to Manage Jenkins, Manage Plugin. And in your case, if this plugins is not installed, then you should be going inside available plugins. Okay. Now, since I have already installed, now I'll be going into a tab called Install Plugins. That's the difference. Okay. So in your case, you should go to available plugins. But now, since I've already installed, I'm just going inside installed plugin, and I'll show you these. All right. So first is parameterized trigger plugin. I have it installed. Next is GitLab plugin. That's also installed. And then you need the Docker pipeline here. Okay. And then check for pipeline AWS steps. That's also installed. And then SonarQube scanner. It's already there. And finally, the plugin called Quality Gates. Okay. So all the necessary plugins are installed, but make sure in your case, go to available plugins and choose all these plugins and install. Okay. Now, once the plugins are installed, what's the next thing we have to do? Okay. So we have to set up some credential, but even before that, quickly, let's go ahead and make sure our build machine has all the necessary things as well as we also have SonarQube up and running so that we can automate the pipeline. So what I'll do, I'll go to the build machine. Okay, so now you can cross check. This machine has close to 4 GB RAM and it has around 15 GB of hard disk. Okay, and it has two CPU, LS CPU, and it will show you you have two CPU. All right, and it's based out of Ubuntu 24. So now, what is that I have to do in this machine? So on my build machine, I need to install Java. Okay, and this is where for Jenkins to connect to your slave machine, we need latest version of Java, which is Java 11. However, the code that I have taken runs only on Java 8. Why I have taken? Because I want you to go through a real-time scenario. It's not always you take any Java and run. So understand, for running my master connecting to a slave machine, I need Java 11. Plus, for our code to compile, we need Java 8. So that is where on this new machine, we need to make sure we have Java 8, Java 11 installed, as well as we also have Docker installed so that we can generate the image. Plus, we will also install the Trivy command line so that you can scan your image. Now, for all these, what I've already done, I've written a shell script, which is again a small use case of how you can use a shell script. Now, this is where again I can make it more fancy. If you want, you can put Ansible code and do it, but for the sake of your practice, it's easy if you just run the shell script. So all you have to do is take the shell script and run, and it'll make sure that it'll install JDK 8, open JDK 11, your Docker, and it'll also install Trivy. All right. So instead of you copy pasting and sometimes you might miss, so everything is available in the repo. Just simply do a clone and execute it. So what I'll do, I'll quickly clone this. Again, it's only for executing this. So git clone. And this is a shell script. And I want you to run the shell script as root, because we are as a user called Ubuntu. So Ubuntu doesn't have privilege to install or update anything. And that's where even if you run the shell script, right, it'll give you an error, because this is why the use case of shell script is coming up. Okay. See, if I run, it clearly says as Ubuntu, you cannot run. So run it as sudo. So what I have to do, just prefix sudo and then run the shell script. So this way, even if I have 2-3 machines, it's very easy for me to take up my shell script. Okay. Let's just wait for some time. Okay, it's now installing Trivy. All right, so it says your build server is ready. So let's cross check. So first, do I have Java? Okay. Do I have Docker? It's available. And do I also have this tool called Trivi for scanning my Docker image? Okay, all of them are available. And I also told you there are two versions of Java. So whenever you take a machine and you have more than one version, always it will be referring the highest version. So that way, what is it saying? The version of Java is 11, but this machine also has JDK 8. So let's cross check. So if you now do a ls and long list, so this is the file. So you can see it's actually referring to user lib Java under a folder called Java 11 JDK. But however, if you go to this user lib folder, you can see you also have a Java 8. So that's when if I access this, right, which is ls user lib jvm and Java 8 bin/Java. What you will be accessing is Java 8. So let me cross check here. If I just say Java by default, it is going to the OpenJDK 11. But now explicitly, if I say go to this file, and now if I say -version, it will give you. So that's how. If you want to access Java 11, just say Java, it will take the default JDK 11. But if you want Java 8, then explicitly you have to refer to this path. So that is something we will do through our pipeline. So far good. So we have our build machine ready in which we have installed Java, Docker, and Trivi. All right, good enough. Now, the next thing what we have to do is we need to install SonarQube. Okay, on the gain, instead of installing and running SonarQube, we can take a Docker image of SonarQube and we can quickly deploy. So that is where Docker is not only for our application or microservices, even any third-party application can be quickly deployed. So what we will do, now let's go to the second machine. This is a SonarQube server. I'll connect to this. Again, so in this machine, all I need is Docker. I don't need Java because Jenkins is not going to connect to this, or we are not doing any build. So what is that I need in this machine is purely Docker. And with the help of it, we can create a SonarQube container. Okay. So again, follow the same steps which is available in the script, or I've already copy pasted here. So you can just run. So sudo apt update, and then go ahead and install Docker. Now, once you install Docker, usually you will not be able to access it as a user called Ubuntu. So for that, you need to make sure that you're modifying the user group of the Ubuntu to add a group called Docker. And that's what we are doing here. Okay. Because, for example, I'll just show you. See, it'll give you an error. So what you have to do is modify, and then you need to log out and then log in again. Only then it will work out. So remember that. Whenever you do a user modification, you have to log out and log in. And now it will work. So now go ahead and create a container out of this image. So I'm taking the SonarQube latest from the open source. Okay. And SonarQube runs on port 9000. So I'm just going to execute it. So as usual, if the image is not available, it is going to download and it's going to create a container. All right. Okay, so now Docker PS, you see there is a container created and it is running and the name of it is Sonar. So I can just say Docker logs and check whether it's running fine. So wait for a few seconds so that this should be successfully start. Now, once it is started, you can go ahead and access the SonarQube from this machine using port 9000. Okay. Okay. So this is up. So take the public DNS and now if I say 9000, should have. So the default username is admin and the default password is also admin. So both are admin. Okay. So now in case if it asks you to change the password, go ahead and change. So the old password is admin and I'll give the new password. Now remember this password. All right. So good so far. So all we have done is one build a machine and we have another machine in which we have successfully installed SonarQube. Correct? Okay. Now to proceed further, what we have to do is we need to add some credentials so that our Jenkins can connect to SonarQube. Our Jenkins can connect to some registry like ECR or Docker Hub, and you can push some images there. Okay, so those are the two things that we want to do. Now, for that, first, what we have to do is we need to generate a token. Okay, and we need to give that token to Jenkins so that whenever Jenkins want to communicate to SonarQube, it will use that token. So to generate a token, go to account, okay, and come to security. Again, where is it? Click on the administrator, my account, and in this, go to security tab. And here you see there is no token, so you can generate a token. Now there'll be two types. So go ahead and take a global analysis token and generate. So copy this token. Now, this is the token what we are going to give to Jenkins. Now, we have already installed the plugin. Now, this is why we need a plugin, because if you have not installed the plugin, then Jenkins will not have any option to connect to SonarQube or any other tool. So come back to Jenkins, and this time go to Manage Jenkins and Credential. So let's add all the credentials one by one, okay? And then we'll try to set up the pipeline. Okay, so there is no credentials so far. So click on global. So the first credential we are going to create is for a SonarQube token. Okay, now for this, make sure you are creating a credential of the type secret text. So that is also important for you to know. Okay, so for different application, different types of credential will be there. So now I don't have any credential. Click on credential to add. And now we have to create something called as secret text. So here, choose secret text. And if you come down, copy paste whatever the credential that you have got. So once again, copy it and paste. Now, for every credential in Jenkins, you need to give a name or a ID. Okay. Now, since I've already developed a pipeline, so what I'll do, I'll try to take a name which I've already given. So that's where you need to remember what name you have given, and accordingly you have to write in your Jenkins file. So here for SonarQube, I've already taken something called as my SonarQube. I'll show you again, but remember. So what is the name called my SonarQube? Okay, now I don't need this. I can in fact give any name, that doesn't matter. If I want, I can still give as my SonarQube. Create. Okay, so now we have one credential which has the SonarQube token. Now, the next thing what I have to do is I need to tell Jenkins where is the SonarQube server and what token that it has to use. So for that, once again, come to manage Jenkins and system. So for any kind of URL or a web application, you should use system. If it is a command line tool, then you should go to tool, that is manage Jenkins tool. So right now, SonarQube is a web application or a URL. So go to system configuration. Okay, so search for SonarQube. So you would get an option here. Now again, this will be available only if you have already installed the plugin. Click on add SonarQube, and now you need to give an email. So the same name I'll try to give my SonarQube, and it's asking for the URL. So copy paste your URL here. So in Jenkins, from now onwards, I refer to my SonarQube as the name or the ID. Immediately it knows this is the URL, and here what credential? The credential just now we just added. So that's why I'm keeping everything the same name. Okay. So go ahead and say apply. That's all. So now in your Jenkins pipeline or the Jenkins file, if I refer to this name, Jenkins knows, okay, this is the server where SonarQube is running, and to connect to that, this is the credential it has to use. So that our SCA, SAST, and code coverage results we will be pushing here. And this is the same place where we will also do the quality gates. All right. So this is the first step. Next, what is that you have to do? Is you need to add a credential for your Docker Hub or ECR. Now here I'm taking Docker Hub as our registry where we will store our Docker images. Okay. Now once again, go back to your security and credentials, and here in the credentials, once again click on add credential, and you need to give your username and password for the Docker Hub. Okay. Now again, what is the name? I'll just cross check here. Okay, so I'll show you this code, and so this time you will choose username and password. Okay, so the username will be your Docker Hub username, and the password will be your Docker Hub password. And for this, I'm giving an ID called Docker Hub. So anytime in Jenkins, if I refer to this ID called Docker Hub, it will use my name and my password. Just like we added one for SonarQube, this is another one. Okay, so this is the second credential. Now, the third thing what we need to add is AWS credential. Okay, now this is needed in case if you are trying to push your image to something like ECR. Now, since we have Docker Hub, it should be good for us. We don't need any AWS credential. Okay. But what we have to do now is we need our Jenkins to be able to connect to SonarQube and validate the quality gate step. For that, we need to add something called as a webhook. I'll repeat why I need webhook. We gave the URL to Jenkins, so Jenkins can come to SonarQube. Now, if you are only pushing some content, we can use that credential and the URL. But when we are doing a stage called quality gate, we want Jenkins to connect to SonarQube and check whether the standard of your code is followed or whether the quality gate step is failing. Now, for that, we need to add a step called what? Webhook. And that is when what you have to do is first, to add the webhook, you need to first give a URL like this. Now, this is where it's a standard URL which you need to remember. I'll just highlight. Change this URL to your Jenkins URL colon 8080 slash sonarcube hyphen webhook. Remember, it's a standard one. So if you don't give this URL, your Jenkins will not be able to communicate to SonarQube for the quality gate step. So what we have to do is I'll take the Jenkins URL here. So be careful when you copy paste everything. Okay, see. So this is my server colon 8080 SonarQube webhook. All right. So now go back to your SonarQube. I'll just open another page. And here, go to administration and click on configuration, and you will get an option called webhook. I'll say if it is small for you. Go to administration, configuration, and webhook. So we don't have any webhook. Create a webhook. And again, you give any name to it, followed by this URL. All right. And then just go ahead and say create. So you have a webhook created in your SonarQube. All right. So that is the next step what we have done. Okay. Now, eventually, there's one more step which you have to do. That is when I'll just show you in the pipeline. So when we try to generate our SAST and code coverage, we will try to push all of them into SonarQube. But since we are using OWASP dependency check for our SCA, by default on the open source SonarQube, you will not be having a support. Okay. So if you want the results of SCA coming from OWASP dependency check to be visible in your SonarQube, then you have to install a plugin for that. Apart from that, the code coverage and the SAST, you don't have to do anything. It's available by default. But additionally, for the SCA results coming from this dependency check tool, we need to enable a plugin. So what do you have to do for that? See, once again, go to administration and click on marketplace. And if you come down, you should see that there is an option called understand the risk. Click on this. And now here in this tab, go ahead and type dependency check, and you see you get this option, and go ahead and install. So by installing it, now SonarQube can show you the results of code coverage, SCA coming from dependency check of OWASP, and your SAST. All the three it can show you, which we can see. All right. Now it's asking for restarting the server, not an issue. Just go ahead and restart. Nothing will happen to your container. It will be intact. Just wait for a few seconds. Yep, should be good. Now, once it comes back, you can just log in and cross check. So now give the new password what you have updated. Okay. So everything is good. And however, if you go to something called project, we don't have anything. So what we will do now, we will ask Jenkins to scan and get all the details, and we will try to upload it into a project. And that's what we are going to do everything. All right. So far, whatever the prerequisites we need, we have done. Just to repeat, we have the credentials added for SonarQube token, and we have also added a webhook. Okay. And we have also added the credential for what? Docker hub, so that Jenkins can generate and push the image there. All right. Now, finally, we'll come back to our Jenkins. Now we don't have the build machine. So this is where let's go ahead and add a build machine. But how are we connecting to the build machine? Through SSH. So basically, your Jenkins will also do a SSH. So you need a credential for your build server also, just like how you do it from your command prompt. Okay. So when the command prompt you run, so you will say SSH, username, IP address, and a PEM file, right? The same thing is what we are going to give it to Jenkins. So what I'll do for that, come back. So manage Jenkins and manage node. So click on new node. Okay, you can go ahead and give a name. So I'll call it as build server. Okay, so I'll keep the executor as 1 and put the remote root directory as temp Jenkins. Now I need to give a label. So I've already choose build as the name. So I'll give the label as build. Use it only with the matching label, and connection is through SSH. And this is where the host, you now come back and go to the build server and take the private IP. And here we have not given any credentials. So instead of adding it here, you can also directly add. So click on add, and this time choose SSH username with private key. And again, you don't have to give, that's okay. So username is Ubuntu. And here it's asking us to enter. So click on this, add, and copy paste your PEM file content. So this is the command we use, right? So, and I'm using a PEM file called master September 24. Let's just cat this. So make sure there are no spaces. You copy. Okay, at the time of recording, it's raining, so I might be sounding a little loud. So now we have the credential added. And go ahead and give this as manually trusted key. Okay. and save. So cross check whether we are able to connect our Jenkins master to the slave. Now this is where, if you remember, in the beginning itself, we have installed Java 11. So we don't have to do anything else. So that's where our Jenkins master should be able to successfully connect. All right. So now we have our build machine also. Now only one last thing I have to do is, now if you are doing a Git clone, you might also be required to give a GitLab username and password. And that is what I will be using for my Git clone. So that's where I'll just create one more credential called GitLab credential. So go back to your security, your credentials, and here add again a new credential of the type username and password. And this time we will give the username and password for GitLab. Okay. Now, in case if it is a public repository, you don't have to give. In fact, the repo what I've taken is public, but it's a good practice when you are try it out with a private repository. So make sure you give a username and password. So here I'll take username and password. So this is my GitLab username and a password. And for that, give this ID as GitLab cred, which is what I have already hard coded. So I'm preferring the same. Okay, so with this, we should be good with our build machine, SonarQube, and we also have all the necessary plugins. So now let's have a look at our Jenkins file, because we are going to automate this entire stages. How many stages I've told? Close to 8 to 9 stages we will try to automate. Okay. So now if you see, okay, so this is the project where we have a sample Spring Boot application. And in this, I already have a Jenkins file. And you can see there are two Jenkins file here. So eventually, I want you guys to first take the first Jenkins file to do only the build. And we will take the second Jenkins file to do both CI and CD, that is build and deployment. So that way, take your Jenkins file and let's go through the stages. Now the machine that I have already added belongs to a group called build. So whenever we run this pipeline, this is going to be a global agent. So all the stages will refer to the same machine. Okay. Then I'm trying to set up some environment variable, which is again global. So for all the stages, this value remains the same. Over here, I'm referring to my account and my repository in GitHub. Okay. So eventually it will go to my account, and under that, it will create a new repo if it is not available. But if it is available, it will try to push into the same. Now, all you guys have to do is change this name to your name. And also, I had created a credential of the type username and password in Jenkins for Docker Hub, and that is what we are referring. So if you go back here, you will come to know So this was the one where I gave my credential for Docker Hub. So what you can do is, if you want, you can change or you give your credential. But eventually, before we start, make sure the credentials is available with the same ID, and then just change the name to your login name of Docker Hub. So to get started, the first stage, what we have is to check out the code. And again, this is a demo, so I'm just taking the main branch. Now you can choose which repo and which branch from that you have to check out. So that's where we are going to do something like CI build or integration build. So however, I'm referring to the same repo here, and in this I'm referring to the default branch called main branch. Okay. And then the actual first stage is to build the code. Now, since it's a Spring Boot or a Java based microservice, we will use Maven to build it. And for that, we are going to call a command or a goal called Maven clean package. So when you call Maven clean package, if there are any existing output files like jars or test cases, or even your DevSecOps scanning, whatever you did, it will delete all the previous output, and from fresh, it will try to compile, unit test, and it will generate a jar file. Okay. However, if you recall on the prerequisites that I had mentioned, for our project, we need Java 8. Okay, because for running Jenkins we need Java 11, and for this project to build we need Java 8. So that's the reason I'm explicitly setting a environment variable called Java home, and I'm referring to the path where your Java home is there. Suppose if you want Java 11, so you don't have to do anything. By default on the machine, when you run Java command, it will always refer to Java 11. But since we want the Maven command to run using Java 8, I am setting up this environment variable. Okay. So what will be the output of this? We will get a Spring Boot jar file under a new folder called target. In fact, Maven will create a folder called target, and all the outputs will be stored in that. And next, we are going to call the second stage called code coverage. Now for code coverage, we are going to use a plugin called Jacaco. Now this is when it's not a separate tool, but a plugin for Maven, because Maven is also based on Java. So all you have to tell is what is the plugin that you need. Now remember, to call the Maven Jacaco goal or the plugin, we have to make sure that the details of this plugin is already available. Why? By default, Maven understands only this goal like clean or package. It doesn't understand any new goal. So for that, we need to make sure in the project's pom.xml or configuration file, we have added the details about the plugin. So if you just go back to the project, now for any Maven based project or Java based project, you will see a src folder and a pom.xml. Now I've already added it for your reference so that you can just go inside and have a look. So scroll down to the end and you should see that there is a plugin called Jacaco Maven plugin already added, and we are telling that to help us in generating a output called jacaco.exe. So when you run the Jacaco, it will do code coverage and it will give us a report in a file called jacaco.exe. Okay, and again this will be available inside the target folder. So unless and until you don't add this plugin in your pom.xml, you cannot call the goal or the command like Maven Jacaco. So anyway, I have added, so we should be able to execute it without a problem. So this way, this output or this stage gives us a file called jacaco.exe, and that will be having the result of the code coverage. Okay. Then the next one is our software composition analysis or static analysis. Now for this, we are going to use again a plugin called OWASP dependency check. So just like Jacaco plugin, you don't have to install anything separately. So just go back to your pom.xml and add a plugin for your dependency check, which is given by OWASP. So which version that you want. And when you run it, this will generate a HTML file and a XML file with the name called dependency check. So that will be the output whether you have any vulnerabilities and do you have any open source dependency in your entire source code. Okay. And once again, if you look at this, we are calling Maven with a specific goal called dependency check. And for that, again, I need the same Java 8. So that way, the third stage what we will be doing is calling Maven and the dependency check plugin. And the output of this will be a particular HTML and a XML file, which will have the vulnerability output. Okay. So remember, each stage has an output. Again, I'll repeat the stage 1, that is build. This will give us a unit test output and it will create the jar. The code coverage from Jacaco, we will get a file called jacaco.exe. And when we run the static analysis using OWASP dependency check, you will get a XML file and a HTML file with the same name called dependency check. Okay. Now, so once we complete our SCA, then we go to SAST. Okay. Now, this is where, if you recall, while I was explaining you this, I mentioned SonarQube has two things. One is the scanner and another one is the actual web application. So what you have seen here is the SonarQube dashboard or web application. Then where is our Sonar scanner? Now, this is the reason why we use Maven, because everything is available as a plugin, so you don't have to install anything separately. So Maven has a built-in plugin for SonarQube, but when you run this goal called Maven Sonar, Maven will try to scan your entire code with the help of SonarQube scanner plugin, and it will find out any vulnerabilities and everything available, and default it will try to push to the SonarQube server or the SonarQube dashboard. I'll repeat again if you're not clear. When you run this command or goal called sonar, that is Maven sonar: Maven, with the help of Sonar Scanner plugin, it will scan your entire application and your code, and it will find out whether your proprietary code has a vulnerability or have you not followed any coding standards. And the result of that, it will not store locally. It will directly connect to a SonarQube server. So that is what scanner will do. It will scan and it will upload to SonarQube. Now this is where the question comes: how does the Sonar scanner know where is your SonarQube dashboard or server? So for that, we are going to use a function here called with SonarQube env, and in that you see I'm giving a reference of a ID. So this ID is exactly, if you go back, you could see that when we configured yesterday, I gave a name called my SonarQube. So whenever in Jenkins you refer to this name, it will automatically know that, okay, you want me to go to this location and this is the credential to access it. Okay, so that way, now when you run this command called Maven sonar, Maven will generate the scanned results of your SAST and automatically it will upload it to the SonarQube dashboard. So that is how the Sonar scanner will know where is your dashboard. And that is why yesterday we had installed the SonarQube plugin in Jenkins and we gave this credential as well as this ID. Okay. However, I told you this. We are not going to just push only the SAST results, but we will also store the code coverage and SCA results, that is all the three results, into SonarQube so that you can do the next step called quality gates. And for that, you can see along with the Maven sonar, we are passing an argument saying where is your code coverage output. So basically I'm saying go to this location that is on your current folder. You will get a target, and inside that there is a file. Try to take from it, or you can also refer to the jacako.exe. Both are one and the same. Okay. So this way you are now telling also take the code coverage result. And further, if you see, I'm also telling take the dependency check results also. What is that? SCA results. And that is where I'm telling it is available in target and a file called dependency check JSON, and it's also available in a HTML file. So you can tell both the file or any file of your choice. Okay. And finally, we are telling the name of the project which it should be appearing in SonarQube is WezvaTech. Why? Because here I'll be having different microservices or different project, right? When I'm doing some scanning, security check, and I want to store all the results, how do I know for which project? So that is how, just like how you have in GitLab separate repo, in Docker Hub also you will have separate repo, in SonarQube also for every product or every microservice have a separate project and store everything. And that is when here what happens now, when the Maven sonar executes, it will collect the SAST results, SCA results, code coverage results, and it will connect to our SonarQube dashboard, and it will create a project called WezvaTech, and it will be storing there. Clear? So that's how in this step we not only do the SAST scanning but collect all the results and store it into SonarQube. Okay. Now comes the next step. So which is what we call it as quality gates. So now we did the SCA, code coverage, SAST, and we collected the results and we have stored into SonarQube. Now, how do I check whether it is within our standards or not? And that's when, if you go back to SonarQube, okay, so there is something called as quality gates. Okay. And this is when for every company, they will be having their own policy, or we call it as a quality profile. Sometimes in interview, they might ask question, what is quality gate? What is quality profile? So a quality profile is nothing but what are the checks that your company want to do to certify that the code is good and the quality gate is success. So if you recall in the beginning, I was telling you, like for example, in my company, I will set code coverages greater than 90%, duplicate lines should be less than 100, vulnerabilities should be below type B. So similar to that, every company can create their own profile and give it. Now for that, you can click on this create, and I'll just show you. All right. So over here, you can see you can add whatever the details that you want and create your own profile. Now, as of now, I'll just leave the default one so that you will get to use to what is there. And it default says if it is less than 80%, it's not a good code, or if your duplicate code is greater than 3%, that is also a indication that your quality of the code is not good. And if the vulnerability rating is anything as A, then also we are going to consider it as a not a good code, or these are the indications where your quality gates would be failing. Okay, so we already have the default, so this is working fine. So now what we have to do, as our results get pushed into it, we need to take this standard and compare whether the output what we have pushed is within our standards or not. And that's where yesterday we installed a plugin called quality gate plugin. So what we will do is we will put up our fifth stage, in which we will check whether the content or the data what we have pushed is matching those standards or not. So for that, once again, we will use a plugin called wait for quality gates. So it's a function from a plugin which we have already installed. What will this do? It will exactly go to our project in SonarQube, and whatever the results we have just pushed, it will evaluate. And that is where have you told, where is the SonarQube? Where have you told what is the project? And that's when wait for quality gate. This is a function. It internally depends on a function called with SonarQube env. So the beauty of the Jenkins pipeline is you run the fourth stage and then you come to the fifth stage, right? So that way, when it executes the fourth stage, it knows this plugin and it knows this ID. Because whenever I refer to my SonarQube as the ID, Jenkins knows it has to go to this URL. And same way, when you call this function called wait for quality gate, internally Jenkins will check before this stage, have you used this function anytime? And if it is the case, it will refer to the same ID. So that is how the quality gate plugin will also know it has to go to the same SonarQube server. Okay. And in that, which repo you have already given it here, right? WezvaTech. So that is how it refers to the previous execution and picks up all the data from this function. Okay. So that's why you might be surprised that I haven't given anything. How does it know? Okay. So it goes and collects the same information. So that way your quality gates plugin will get invoked in the same SonarQube dashboard, and it will try to check with our default standard what we have given. Okay. And all it will do is give the result. Okay. So if everything is fine, then you will get a status called okay. If there is an issue where the profile or the standards what you have given is not matching the code, then or the results, then it will say not okay. So that is where what we are trying to do is we are trying to check the status of this plugin, whatever it is returning. If it is not okay, then consider your quality gate has not passed. And if my quality gate is not passed, then I'm forcibly marking this stage as failure. And I'm printing that I will stop the pipeline because your quality gate is not success. So that's how you can guarantee any code which is going to the next stage has passed your quality gate. And any chance if your quality gate is not passing, your pipeline will break and stop then and there. Okay, cool. So far, now we guarantee that you do SEA, SAST, and you do the code coverage. You push to SonarQube and you check whether they are within the standard. And only if they are within the standards and you guarantee that your code quality is good, we move to the next stage. And the next stage is we do the build. And once again, many people I have seen, they just write the standard commands like docker login or docker tag and docker push. Now that's not a good way, or that is not an actual real-time way of writing the code, because you should not hard code any commands or credentials. And that's where we also have a plugin for that. And if you recall, we have installed one more plugin called as Docker pipeline. So because of that, we will get a function called Docker with registry. Now for this, all I'm telling is use this credential. So what is this registry credential? If you go up, it's a variable where it is pointing to an ID called Docker Hub. Okay, it's just a name. And what is this ID called Docker Hub? If you come here, so it refers to my username and password. So that is where whatever the Docker Hub username password you have given, it'll exactly come here. And now whatever the commands you are trying to run within this stage will be exactly going to Docker Hub under your account. Okay. This way, you can take the same code and in fact, you can push to any other repository in case if there is another microservice. So that's the reason you really do not have to hard code or give any command. So all you have to do is now call a function called docker.build, and this is equivalent to running a command called docker build -t followed by the name of the image colon what tag you want and followed by dot. Okay, let me show you what is that. So generally when you try to build an image, you will say something like this, right? The image name colon a tag and then dot. The equivalent of that is what this function is going to do. Okay, so now what is the name of the image? You're not telling. And where is it taking it from? It takes everything from here. All right, so that's how. Only if I change the name on the top, I'll be able to build and I'll be able to push this image and whatever the registry that I want. So that's where when you are writing code, real time means you should be able to reuse the code. That's why we use Jenkinsfile. Okay, then when I call this function called image push, now this is exactly equivalent to running the command called docker tag, and then you give your image name followed by where is the repo, where is the, okay, actually it's where is the registry, where is the repo, and what is the actual tag name that you want. And then you will say docker push and you have to give the actual name. But instead of giving all these commands, when you use this function and say image push, now what is the name of the image? My account slash demo CICD. This is the one. So where it will push, it is automatically going to push to Docker Hub, and that also with the credentials what I have given. Okay, so that's where there's nothing to hard code. And I have not given a tag, so it will always create a tag with the name called latest, because what is the behavior of Docker? When you build an image, if you do not give a tag, it will always create a tag as latest. Now I'll show you how to change it in some time, but for now let's see how it actually works. So what will this do? It will build an image called demo CICD latest tag and it will push to my Docker Hub account. Okay, and then the next step what we do is check whether your image has vulnerabilities. Okay, and that's when in your seventh step we call Trivi and we go ahead and scan the same image what we have built. So if you can see, this is the name of the image what we have built in the previous stage, and we are going to run the scan. And what we are doing, I'm redirecting the scan output to a file called triviresults.txt. Why? Now many times you will see YouTubers or people in Google will say, okay, you need to do a scan and for that you run the command called trivi. Well, that is correct. But what you should do after running the scan? Well, just like what you did a quality gates in the beginning, you are not just going to run trivi and stop. You need to find out whether Trivi has told you whether this image has vulnerability or not. And if it has vulnerability, you need to stop your pipeline again. Where are you going to do? And that's where we are not just running the Trivi command, but in real time, I also want to redirect, which I will use it further to check whether my image has vulnerability or not. So that way, your seventh stage is to scan that image. Okay. Now, scanning is done, and the next step immediately that I'm going to is to do a smoke test. Now, why I'm not checking whether my image has vulnerability immediately? Because see, the logic is sometimes what will happen when you are building the application and you're preparing your release in initial time, even though it has vulnerability, some companies will say, okay, don't focus so much into that because the time you take to fix the vulnerability might be 2 weeks or 3 weeks, and your overall release itself is 2 months. Then should QA be waiting for almost 3 weeks without doing any testing? So what they will tell logically or in real time is, we as DevOps team, we will be working towards how to fix those vulnerabilities. However, QA will further go ahead and test whether the application functionality is working fine. But at some point of time, we need to make the rule saying, okay, in my pipeline, beyond this day, if image has vulnerability, I will not even allow further. But until then, I don't want to really do it in the beginning. But that's where what we will do, we will now try to do a smoke test. And what I have done in this example is, along with the smoke test, I will also check whether your trivy has told any vulnerabilities are there. So that means, once again, it is acting like a small quality gate here to ensure your image generated is working fine because I'm able to do the smoke test, and at the same time, the scan output of Trivy, whether it has vulnerability or not, you can find out. So that's where you can decide what to do and what not to do. So for this, the last stage is to do the smoke test. Now, what is smoke test? Like I told you, it's just about starting a car and check whether your engine is starting up, your basic electricity supply is there in your car. So same way, just create a container and check whether the container is successfully running, and then access the application and check whether your port is accessible. Now, since it's a Spring Boot, the default port of the application what we have built is port 8080. Okay, so if you look at it, all I'm trying to do is create a container, okay, with the same latest image, and I'm mapping a port called 8080, and I'm waiting for a couple of seconds because this is the basics of Kubernetes. Okay, now for those who have already gone through the class, you will know in Kubernetes, as soon as your application is started, you will not be able to access because there is something called as a starting period, right, or an initial delay. So just to make sure you don't have an issue there, similar way I'm trying to do is wait for 90 seconds and then I'm running a shell script here. So once again, I'm giving you real-time use cases on where and all you can use shell script. Okay, so here I'm using a shell script to find out whether my container is running successfully the application, and also I will check whether the image has vulnerabilities or not. Okay, so let me show you what the content of the file. So let's go to project, and you see this is the shell script I've already stored in the repo. So what I'm doing, I'm trying to check whether your localhost port 8080 is accessible. And again, as a DevOps engineer, some of the basics you need to know is, whenever you access a web application, if it returns a code, there is a meaning for each code. Okay, so basically there is a error called 400 or a code called 400, 500, that is 3xx, 4xx, 5xx. Let me explain about this in another webinar deeply. But if you are accessing a client, or in simple words, you are accessing a web application, and if that web application is returning you a code called 200, that is HTTP 200, then consider it's a successful call. Okay, so all I'm trying to do is that. So if I access localhost through a curl command, and if I get a return status 200, then it means my application is working. In fact, it means my container is working. And the same time, if you go to this results file, which was output of your Trivy scan, you will get a lot of output. In fact, the image what we have taken is a open source, so definitely there is a vulnerability. So you can go to this and explore it later. But all I'm just trying to check is, do you have any input called critical? Okay, and I'm not failing the pipeline. So all I'm doing is putting a condition saying, if there is vulnerabilities which has been found out through Trivy, and the script will just print saying you have vulnerabilities. So the output of the script will tell me whether my smoke test is successful, and at the same time whether do I have a vulnerability or not. All right, so that's going to be the output. Now once it is done, then I'm just going ahead and deleting the container that I created. Okay, so this marks your end of the DevSecOps build pipeline. All right, So now let's see how this gets executed in practical. So what we will do for this, I'll go back to our Jenkins. Now we already have our build machine ready. So let's create a new pipeline. Again, remember your CI/CD is not a single pipeline. So what we are focusing is the build pipeline to make sure we have a deployable artifact, which is Docker image, where we are certifying it is good for testing and it doesn't have vulnerability. Okay. So we'll call this as Spring Boot build pipeline, and it's a type called pipeline. Okay. And this is where instead of using freestyle, we recommend to use Jenkinsfile because it's a declarative approach and it's a code, so I can reuse it how many ever times for whichever branch I want. Okay. All right. So I'll just come down to the pipeline and let's give the reference of this repo. Go to SEM and Git, and here give the URL. Now, if your repo is a private repo, then you have to give credential. But as of now, my repo is public, so any one of you can access and practice. So I don't have to give the credential. And then it's asking on which branch. So change this to whatever branch you want. So right now for me, it's main branch. And what is the name of your Jenkins file? So as I said, we're going to take the first file, which is Jenkins file. So nothing to change. All right. So go ahead and save. All right. So go ahead and do a dummy build for now and check, is there any errors or everything is working fine? Now you can see the stages here. At the same time, if you want to look at the output, console output, click on this and you will get the console output. So let's look at how this is progressing. Yeah, whenever you're trying for real time, don't just try with T2 micro or small machines, take larger machines. All right, not a problem. It says there is some problem with the build stage and you can see the entire steps has been skipped. So let's look at why it failed. Okay, so it says on this machine, Maven is not found. Well, let's cross check. Let's go to build server. This is the one 172.31.42.252. Let's cross check whether there's a machine. One 172.31.42.252. All right, that's fine. Now let's connect. So which Maven? Okay, Maven is not installed. Why? So if you go back, this is the setup shell script we had. And if you had looked at it and had purposefully put it up in such a way that you should get error so that you debug and find out. So what and all we installed in this? Java 8, 11, Docker, and Trivi. We didn't install Maven. So we have to make sure Maven is also installed. So all you have to do is go back and just say sudo apt install -y Maven. I'll just take a latest version of Maven. So what I'll do, let me add it into the script so that you guys can go through. You don't have to get into this problem. So I'll just add Maven here. Anyway, I have committed. So if you guys run the shell script in the beginning, everything will be installed. Fine. So now, which Maven? It's available. So let's come back to our pipeline and let's trigger the build again. It's going through. And meantime, I'll just try to take the console output of a second build and see how it is going. So now it's going through the build. Okay, so it's checking out and it's go to the main branch. And first, what does it do? Come down. You can see this is the first stage where it is running the command Maven clean package. So for the first time, Maven will download all the plugins, so it will be a little slow, but after that, it should be faster. Okay, I think it came to the next stage. It's completed. Then it's going to the code coverage stage. Okay, and yeah, it's actually too big of output. In the next output, probably you can see. So it has executed the Maven Jacaco plugin, and now it started calling the next stage, which is third stage, that is software composition analysis, and it is calling the OWASP dependency check plugin. And that's when you should see that it's scanning. Okay, so what will dependency check will do? Check for any open source dependencies or third party library vulnerabilities. And you can see it has a huge list from the time where it was formed. Okay, so every year there will be updates in the OWASP where they say what are the new vulnerabilities. So this check or the tool will check for every vulnerabilities until today. Okay, so that's how it will take some time. Okay, so let's just wait for a few more seconds. Yeah, it's still on 2008. So again, there's a small database which it maintains locally also. Okay, so don't think as a big database. It's a small data which maintains. So the second time when you run, that would be faster. But eventually, first time it would be taking a lot of time. Okay, so that's where in real time, sometime companies might feel to run this in parallel along with your build stage. If you want, you can do, because there is no dependency for the build in this. That's why we call it as static analysis. So by the time you do build, you can also do in parallel your SCA step. Okay. Okay. 12 more years. It's 2012. just in case. So this is my repo, which I already have. So we should be seeing that the images, whatever we build, we push it here. Hmm. 4 more years. Okay, it's kind of slow. Okay, it's almost there. Let's wait for a few more seconds. It's just updating its local database that I was referring earlier. All right. Okay, so it's completed the scanning. Okay, and it says some vulnerabilities are found, which we will see, right? Because anyway, that will be shown in the SonarQube. So now what is the next stage is our SAST. And that's when our sonar command is going to be called. And when the sonar command is called, okay, so it'll exactly do the SAST scanning, take the code coverage, SCA and SAST all together to the SonarQube dashboard under a project called WezvaTech. So if you scroll down, yeah, because of the first time it Maven is downloading all the plugins. Okay, but now you can ideally see. So here it takes all the values one by one. Okay, all right. So it completely took, and now it says it's uploaded into this dashboard, which is nothing but the URL of our SonarQube. And what's the next stage is quality gates. Okay, you can also cross check. Your SAST is done. It went to quality gates. And what we are doing in quality gates, your Jenkins is now connecting to SonarQube once again and checking for this evaluation. And it's saying that everything is good. That means our code passed our quality gate. And only then it's going to the next stage in which it's trying to run a build. You can see the command and what image it is generating, demo CICD latest. And this is exactly what it does in the build stage. Okay. And once the image is built, it is going to run the same Docker tag command and Docker push, and it is going to push into Docker Hub. All right. I'll show you that. And once that is done, then comes our Trivy. Okay. Now Trivy is running, and obviously this will also show some vulnerabilities in it. And then the next stage is the smokes. And in the smokes, we are trying to create a container and wait for some time. Now, quickly, if you want to check whether the application is up, you can also cross check that. Anyway, it's waiting for 90 seconds. This is the build server. If I quickly go here and say 8080, well, this is our sample application. Okay. So it's a sample Spring Boot, which kind of has some plugin to monitor a live car. Okay, I've just taken some random code, so you don't have to worry. But ideally, come back, and it's still running. And what's the result? So I'm just saying that your smoke test passed, which means you're able to access the application, and that means your image is also good. And now, even though there is vulnerabilities, you can see it clearly says your image has vulnerabilities, because if you open that text file from the build machine or from the build workspace, you will see. But like I said, for our practice, I don't want to fail this pipeline. So all it is doing is printing the message, and now it completed. So eventually your pipeline is completed. So assuming that this is success, you should see that there is a image pushed here, which is latest. See here, just now. All right. So this is how every time when you run a build, only when your pipeline goes through all the stages and you collect the necessary things, right, and verify whether your code is good, and generate the image and also verify your image is good and then hand it over to testing. All right. So this completes what we call it as a build pipeline. But to again step back, what is that we want is a CI pipeline, CICD. So what is CI? As you were understanding in the beginning, CI is just a process where as soon as a developer commits a code or pushes the code, and I want this pipeline to be triggered automatically. So all you have to do now is you have the Jenkins file, everything is ready. Just make sure whenever a developer commits a code to a particular branch in a repo, trigger this pipeline. Okay, so that's what we want to do. So for this, what we have to do is go back to your repo. Now, whether it is GitHub or GitLab. Now, in our case, we use GitLab. So I'll go to the same project. All right. So in fact, the same project here. Now, in this, first, we need to make sure your Jenkins can access GitLab through a API. Just like how we added a webhook between Jenkins and SonarQube access, now GitLab has certain API which can trigger Jenkins. Because in old method or in a traditional way, we used to ask Jenkins to connect and check whether there is a new commit in the GitLab, because that would be too much of performance issue. But on the modern method, applications like GitLab has an API called Webhook where your GitLab can trigger Jenkins. So this is where, similar to what we did a webhook in SonarQube, we are also going to set up a webhook for a particular repo. So for that, we have to generate a token. Again, same thing like SonarQube. So generate a token for GitLab and give that to Jenkins and generate a webhook in your GitLab and access the Jenkins through that. So what we will do now, go to your account. And go to preferences. Now under this, you should see something called as your access token. All right. Now if you already have a token, generate a new one. So I'll delete it. I'll generate a new token. All right. So I'll call it a demo. Any name can be given, not a problem. And you can also give an expiry date and what and all access you want. So right now I want to give only read access. I'll read repository and read API. So only these two. Come down and go ahead and generate. All right. So make sure you have a copy of it. And if you recall, we have already installed a plugin called GitLab plugin. So this is when go back to Credential, add a new credential. Okay. So now choose something called as GitLab API token as the type. So come down, copy paste your token and go ahead and give some name. So I'll just call it as my GitLab token. Okay. Again, now Jenkins needs to know where is your GitLab. Exactly like what we did for SonarQube. Go back to system configuration. So manage Jenkins and system configuration. And under this, since we have already installed the GitLab plugin, search for the tab called GitLab and give this URL. So since we are using the open source GitLab cloud, so you can just copy paste this only. So search for GitLab. So you see this. Now remove this option and it's asking to give a name. All right. Now this is when the URL will be GitLab and you can again give any name. All right. So whenever I refer to this, Jenkins will know that this is the location and what is the token? is this token, and just do a test connection and check whether it is working. Success, which means my Jenkins and GitLab can connect between each other. All right. So now we have to create a webhook. All right. So that's important. And that's where now go to your particular project. Okay. So the token was for the entire GitLab, but for which project, whenever there is a commit, you want to set up the CI pipeline. So go to that particular project. So this is my project. So here, go to settings, and in the settings, you have webhook. So remember, webhook has to be specific to the repo. All right. So now you can add a webhook, and this is where you need to give the pipeline. So what is the pipeline? So you need to take this. Okay. However, there is a standard that you have to follow. Like how you gave here, what you also have to do is, whatever is the name of your project or the Jenkins job, don't give it as job. So here you can see it says URL 8080 job Spring Boot. So instead of job, call it as a project. So that's one small change you have to do. Just like the webhook that you had for SonarQube had a naming convention, here also you have to give. So it has to be your URL colon 8080 slash project and the name of your job. All right. So let's come down and go to GitLab. Sorry, here, and give the URL and come down. And now you need to tell for what you want to trigger. So that's where from GitLab, you can call it for a commit that you are doing on a particular branch, or you can also call it for a merge that you are doing from one branch to another branch. So there are a lot of options. So for now, for CI, on a particular branch like feature branch, whenever someone or a developer commits a code, I want to trigger. So we'll go ahead with push event. So click on this, and you can also choose which branch. So right now I have only one branch, it doesn't matter, but if you want, you can change it. So scroll down, okay, and just remove this because this is not a production GitLab, so we don't have any certificate for authentication, it's just a token. So remove this and just go ahead and say add. So now you should get a webhook. Now you can cross check first whether your GitLab is able to reach Jenkins. So for that, come here and click on this and click the push. So you see you get a 200 message. So again, just the same smoke test what I said. So what does this guarantee us? Your GitLab is able to reach Jenkins. But in fact, whenever you do a check-in, I want this automatically to trigger a job. So let's go to Jenkins and see what is happening. This is our Jenkins job. It didn't trigger any new job. Why? Because this is where all you have verified is GitLab can call Jenkins. But that is when in the basics of Jenkins, you need to tell something called as a trigger. So when you should call. So for our testing, we triggered it on on-demand basis. But the other options you have is you can give a schedule, or you have to now configure and tell to allow the event coming or the webhook coming from GitLab. So that's where go to the job, okay, and you add a build trigger option, which will allow a GitLab webhook to come. So that way, so come down and you should see the build trigger and you see an option. Now this is visible because we installed the GitLab plugin. So now it is saying that whenever a change is pushed to GitLab, allow. Just go ahead and allow it. Now, if you don't want it for any merge request, then remove, keep it only for purely for a push event, which means when a developer commits and pushes a code to this repository, I should be able to trigger the build. All right. So let's go ahead and apply. And now to test if I trigger, I'm not going to do a commit, I'll do it later, but as soon as I call my webhook, what should happen? You should see this will call the Jenkins, and Jenkins job should get triggered, and we should have a build triggered. Okay, come back and let's look at. All right, and you see now you have your build triggered automatically. By whom? It was triggered by me. How? Through a webhook. So this is how your CI build is ready. So there's nothing fancy. So all you have to do is set up your build pipeline and make sure you have a ability to trigger. So that way now whenever there is a commit and a push happening on my repository, the build will get triggered automatically. So now this pipeline is called as CI build pipeline. That's all. Okay, now I have the flexibility. So whether I want to make it a CI, or I can schedule, or I can run whenever I want. All right, cool. So far, all we have done is in the CI/CD, the first part on having your build pipeline. So anytime when a developer commits a code, so now we will generate a deployable artifact called Docker image, and we tell whether it is good for testing and it doesn't have any vulnerabilities. If not, we should go back and indicate the developer saying pipeline failed, please have a look at it, or we need to help the development team in fixing some of the issues like any vulnerabilities which are there. Okay, now what's the second part of your CI/CD, which is deployment. So once again, first let's look at how we are going to do the deployment, and then we will set up the pipeline, and then we will introduce the DevSecOps. All right. Now for that, what I want you to understand is, now what do you mean by deployment? Now ideally at this point of time in the market, whenever we say deploying your application as a container, we will deploy it in Kubernetes. Okay. So being that, so now assume I have developed some YAML file in which I will tell what are the objects that I need to run my Docker image that we have generated and pushed. So let's say, for example, I have created a deployment object and a service object or a config map, whatever that you want. So now in a traditional deployment, what do you do? So there will be a Kubernetes cluster like QA cluster. And for that, there will be a separate machine, a workstation in which you will have a kubectl command. So you first download or do the clone of your YAML files from where you have stored, and you just run the kubectl apply command, and the code will be taken to the cluster through the API server, and the API server will create your pods, deployments, services, or basically it will create container and run the application. And this is where most of the people, what you would see, will say, okay, you want to automate it, you can use Jenkins. So now we have already written our pipeline. All we can do is add one more stage in which we will say from the same build machine, you run kubectl command, and that's all. Because once you run the kubectl command, everything will go to the site. Now, this way of doing it is a big no. And in real time, we never ever do this. Why? Because, first of all, your Jenkins or the build machine will have access to the Kubernetes cluster. What if it is a production? You will build and immediately you will run? That is not at all possible. Why? What if a user goes to the build machine and he can access the Kubernetes cluster through the kubectl? So which is where it's not a secure way of doing. Okay, so don't go just with the fancy tools, but understand the reality. Never ever use Jenkins to run your Kubernetes commands or kubectl command, because your Jenkins has access and any user can access Jenkins. So that's the biggest issue for DevSecOps. And second thing, now when you set it up as a pipeline, you build the image. So it is a new image you will build, and what will get deployed? The same new image is what getting deployed. So every time when a developer modifies the code and pushes the code, his latest code will be taken. We will generate a new jar file from his latest code. We will put this latest jar into a new image, and that new image is what we are deploying in container. Correct? But what if QA wants to deploy a old build, or they want to redeploy? And basically what I'm asking is, I don't want to do the build, I just want only the deployment. So how do you stop your pipeline, or how do you tell the pipeline, don't do the build, just go to the last stage and deploy a old image? So that's once again not possible in your traditional CI/CD if you use Jenkins to do that. Okay. And the third and important most thing is, in reality, we are not going to have one environment. So ideally, we are going to have QA environment for your functional test or integration test. You have staging environment for UAT, and you have your production for customer. And so when I say CI/CD, I will build. Where will I deploy? How will you deploy to QA? How will you deploy to stage? How will you deploy to production? So in one command, how will I put everything? And even before that, you have to do testing. And that's exactly the requirement where in DevOps, what you need to understand is, we are not going to do in real time one pipeline. Okay. Because I want to do a deployment to QA separately and then separately to stage and production. So this kind of pipeline will not at all be useful. And that's what in the beginning I told you, keep your build pipeline separately and deployment pipeline separately, so that we can achieve the security, and at the same time, I can deploy to any environment I want. So that's what is going to be the real time. So how are we going to solve? And this is when, in the modern CI/CD, when we think of security as well as how do you ensure you have the ability to only build, only deploy, or both build and deploy, all this combination is not through Jenkins, but by introducing another concept called GitOps. Okay. Now, for those who are not completely familiar with GitOps, now I have already put a video in the channel long back. Go and refer to it. But anyway, I'll try to give an overview of what exactly is that. So, like most of the tools in your DevOps, right? Like your Ansible, or in fact your Kubernetes or Terraform, GitOps is a concept where you tell your desired state, and there will be a tool or automation which will help us to achieve. So rather than going through your traditional method, like you take the kubectl command and apply and then change everything, in the GitOps method, you don't even have to run the kubectl command at all. All you have to do is take your YAML file, like your deployment YAML file, service YAML file, or a pod YAML file, and give that to the tool, or what we generally call it as a GitOps controller or operator. And what will that tool or operator do? Go to the cluster and it will do the actual deployment or upgrade. So this way, a user doesn't have to even access the Kubernetes cluster. So all we have to do is make sure that we have a tool like Argo CD, because that is one of the popular tool that we use. I mean, you can use any other similar tool. So I'm using Argo CD for that. So now if I install Argo CD in my actual Kubernetes cluster, and we give the reference of a Git repo where we have our YAML file. So now we have a repo for our source code. Like that is where we did our build, image creation, scanning. That is separate. Now we are going to have a separate repo to store our Kubernetes YAML file. So that is what you are going to refer to the Argo CD or the GitOps controller. So this way, what will happen? You want to do a deployment, make sure that Argo CD or similar tool is monitoring, and go and change your YAML file. Because now if I want to deploy build one, I will just edit the YAML file and say build one, and immediately Argo CD will find out, okay, you have modified something. I will go ahead and deploy your build one. And if I change it to build 10, it will go ahead and build and deploy that. Now, what if I say, oh, now I don't want build 11, but I want to deploy build 3 for some reason? Then just go here and change your YAML file by changing your desired status. Hey, I want you to deploy build 3. That's all. And immediately Argo CD will take that and it will go ahead and deploy. So this way is too secure because you don't need a pipeline or you don't need a user to go to a cluster or run any kubectl command. So typically keep your desired state, that is your actual YAML file of your Kubernetes, in a repo, and let a tool like Argo CD monitor and connect to your cluster. So the Argo CD or a tool similar to that is what will be connected to the cluster. All right. So eventually what we are going to do is, now let's first see how this can be achieved. Okay. So this is when I'm just stepping back for a minute, all right, to my repo. And this is where, if you go back to my projects, and you can see there is one more project called Spring Boot CD pipeline. So the build pipeline repo has the source code for your build, a Docker image, scanning, and your results, shell script, all those things. And similar to that, I have another repo called Spring Boot CD pipeline, and this has the code for our deployment. Okay. Now in this, you see that I have a separate folder called Kubernetes, and I have a simple two file. One is deployment.yaml. So basically all it will tell is, take an image that I give, all right, and deploy and create an object called deployment, and how many replicas I want? 2 replicas. All right. And it's going to expose a port 8080. And the same time, I have one more YAML file for an object called service, and I'm telling what is the type of service, node port, and you expose and map to a port called 31000. So if I run my image, I should be able to access a port called 31000, which direct me to a service node port, and that will direct me to any pod. All right, fine. So now this is when, how do you set up your Argo CD? So that is where, whatever the clusters that you're going to have. So again, don't go with anything fancy for practicing, but I can take a small cluster, or you can take a EKS or AKS, any cluster that you want. But preferably what I'll do is take a separate machine now and install a tool like Kind or Minikube, using which you will be able to quickly get a cluster for your practice. All right. So what I'll do, let me create another machine now for my deployment, and that is where I will install Minikube and create a small all-in-one cluster. Okay. So again, for that, I need a minimum of 4 GB RAM to run. So we already have 3 machines. So I'll go ahead and create one more machine, and I'll call it as Minikube server. And again, it's going to be from Ubuntu latest 24, and I'll take T2 medium, so which is 4 GB, and I'll take my default PEM key pair and we'll put it again under default. All right, should be good. So wait for some time for the new server. Now once the server comes up, all right, I want to install Minikube. I've already given the instructions here. You can just take the same. Now again, Minikube runs on Docker, so make sure you have Docker first and then install and run Minikube. Okay, so we have our server. So let me connect. Now make sure you run minikube as root. Okay. So here you can just follow this instruction. Go ahead and install Docker first, and then install kubectl, so that initially if you want to look at something you can do, but we don't need kubectl anywhere for our automation. But since you're practicing, you might have to just check few things, so you can use kubectl. So I'll install, oh, it's not yet installed. So I have which kubectl, and we also have Docker, and go ahead and install minikube. And what you have to do is you need to start minikube, but before that there's one more dependency of a package called contract. Install that also. Now you need this if you are using AWS. I'll now go ahead and start minikube. So only if your machine has minimum of 2 CPUs and 4 GB, your minikube will also run. That's the reason I said take a little larger machine. Right, so once everything is done, we should have our cluster ready. So we will go ahead and then install Argo CD in it. And it's very simple and easy. And I prefer it a lot because it's not just easy, it has a beautiful dashboard. Okay. And instead of running any commands, you can just look everything and you can debug, so that as a user, a QA guy or a dev guy or an operation guy, they can have this dashboard itself, which is more than sufficient for them to do their day-to-day work. Okay, so let me show you how that looks. Okay, your minikube is bringing up the control plane of your cluster. So again, so we have two things, right? Control plane and data plane. But now everything is in this single machine. So now I go ahead and say kubectl get nodes. Well, you see there's one machine, so you can use this for your practicing. All right. So now let's install Argo CD. So again, you need to run it on a separate namespaces. So that's the basic. Any application that you're running always have a separate namespace so that you don't mix it with your microservice. And what we will do, we will try to run this file against that namespace. Okay. So it goes ahead and creates all the objects that it needs. And now, so basically it will create a service so that we can access the Argo CD application through web. But the default port for this will be cluster IP. So we need to change it to node port. Okay. Now you can use this command separately, because if you try to edit the original file, it's a huge file. And if you mess up, nothing will work down. So first check, you should have a new namespace called Argo CD, the first one. And now if I just say kubectl get pods -n Argo CD, wait for this to come up. And same time, you can just say get service. And you can see there is something called Argo CD server, and the type is cluster IP. So this is where I want you to run this command. And now if you check, only this will be marked as node port, and it is going to run on a port called 31,881. So now if you access 31881, you will be able to access the Argo CD application. Meantime, check whether all the pods has successfully run. Yeah, everything is running. So now just go back to your server Yeah, this is the mini cube. Take the public DNS, and if I just say 31881, I'll just close. What do you see? Okay, go to advanced, and now you are able to access Argo CD dashboard. So again, the default username is admin, but to get the password, you need to run a command. So go back to the page. Here I have the command. So run this command. So the password is this. So copy paste. All right. So now you have your Argo CD up and running. So now I need to tell the details. So first you need to tell where is your repo and for what application you have. So you need to tell two things. One, your location of your repo, which is GitLab. And second thing is, where is your repository in which your YAML file is there? That is our CD pipeline repo. Both the things you have to tell. So first, go to settings and click on repositories. And here, click on connect and use HTTPS and give Git. So this is our GitLab, which is nothing but Git. So come here to your repo, right? Take the URL and give the name of the project as default and your URL and give the username and password. So this way, in case if it's a private repo, your Argo CD will connect to the GitLab and it will do a clone and directly apply it to your Kubernetes cluster. So that is where you don't need Jenkins or a user to do that. And password, all right, and nothing else. Go ahead and connect and check whether it is working. So you can see Argo CD is able to connect to this, but we haven't told where is your actual repo. We have just told only the location. So this is when we need to create something called as an app. So now why we call it as app? Because using this one repo, I can deploy to my QA for my functional test. I can connect to my UAT or production cluster and I can run it for my UAT or production. So that is where you just have to create different app which refers to different location. So that's where now go ahead and create an app, okay, and give a name. So I'll call it as demo. Once again, you can just leave the project as default. And in Argo CD, there are two ways to automatically run. One is called as manual, another one is automatic. So automatic means whenever you modify the file, automatically it will go and sync. Now this is okay for QA and UAT, but in production, we should never do. Why? Because someone has to approve it. That's the real time. So in those options, if you go with manual, when you modify, Argo CD will find out, but it will wait for someone to approve. So only when someone approves, it will go to the cluster and change. So that is where you control. So depending on which cluster, whether you want automatic or you want manual. So I'll keep it as manual so that you can also verify and come down. And this is when it is asking, okay, whenever I refer to this demo app, where exactly is the code? And that's where you're going to tell now the source is in Git. And if you click, you can see it's referring to the repo just we added. And then it's asking us which version you want to take. You want to take the latest, it is okay. And the next one it is asking us, in this particular project, do you have in a particular child folder in which you want to check? Because this is how it's not mandatory that it should scan everything. So if you come back, I want this to scan only my Kubernetes folder because this is where I have my file. So all I have to tell is take this and tell the path is folder called Kubernetes. So under this repo on my main branch, check for a folder called Kubernetes. Okay. Then this is your desired state. Now, what is your actual state is the destination. So where is your cluster? Now that's where you can give the same cluster or you can also give another separate cluster also. That's the flexibility of Argo CD. But for practicing, let's take the same cluster. So I will say refer to the local cluster and where you want to run. So I will say run it in a default namespace. So if you go to Kubernetes, you know, whatever we run, everything will be in a default namespace. So that's what I'm trying to tell. And come down. And do you have any other options? Nothing. Just go ahead and create. So now you see we are not at all going to cluster. All right. But what is Argo CD doing? It is now going to your YAML file and it is checking this, and it is going to our cluster and it is trying to check that in the default namespace, do I now have a pod with the name called WezvaTech, and does it have two replicas generated from this image? Okay, so if it is not there, and then come and see what is it saying, it is missing and it is also out of sync. Out of sync means your actual cluster doesn't have that, but your source has it. That means desired state is there, actual state is not there, so you need to sync. So that is when, since we have enabled as manual, it is not automatically syncing, so you need to go ahead and click on sync. And before that, the reason I called it as beautiful, because you see it clearly understands from your YAML file, this is your app. Now for that you have a deployment object and you have a service object. It clearly identifies it. So if I now just say sync, okay, it clearly says I'm going to create an endpoint which is nothing but a service IP, and for your deployment, what does a deployment object do? The basics of Kubernetes. It will create a replica set, and now that replica set you see has two pods. Okay, ignore the error, whatever it is saying, not a problem. But do you understand how it is working? So instead of we going to the cluster or the machine and do the git clone or create the YAML file and then you modify the image name and say kubectl apply, all you have to do is take your YAML file as the source, keep it in the git repo somewhere and refer your Argo CD to it. So that is how anytime when you modify your YAML file, Argo CD will find out and automatically update. Well, this is what we call it as our modern deployment. But however, we have not completed. Why? Because now if I want to deploy, should I go to this particular repo and modify? Because if I want QA to deploy, then QA have to come to this place. They have to edit this file, change the image. Well, that is again not a good practice. What if I want to deploy to production? So that's when, how do you control and how do you automate? And that's exactly where we can think of a pipeline again. Okay. So now let's think of having a pipeline for deployment which can automate whatever that we did. So we have a GitLab in which YAML file is stored, and we also have a Kubernetes cluster in which Argo CD is continuously monitoring. So all we will do now is we'll create a Jenkins job and we will call it as a CD pipeline, in which instead of you going to the GitLab, you call the Jenkins job and give the name of the image what you want. And what should your Jenkins job do? Jenkins should connect to GitLab, update whatever the image that you want, and stop. And as soon as the update happens, what will Argo CD do? Argo CD will simply take the latest code and then deploy. So that is how your CD pipeline is going to be formed. So once again, we will use Jenkins, but that's where now it's a second pipeline that we are going to create called as CD pipeline. And we will allow the update for our YAML files in GitLab through this pipeline. All right. And exactly, this is where, if you go back to the same project, I have already developed a Jenkins file. Okay. So now if you edit this Jenkins file, there is a simple stage in which we will first ask the user to pass what is the tag name that you want and update that tag in your YAML file. Okay. And go ahead and commit and push it. So this way, whenever you run this pipeline, you need to give your tag. So which image you want to deploy. So that is how it could be a new image or it could be a old image. So you have the control. So as soon as you do that, this pipeline will update the same repo with your image tag. And as soon as this commits, what will happen? Your Argo CD will immediately say that I see there is a change and it is out of sync. And since we have given it as manual, it will ask us to sync. If not, if you have made it as automatic, as soon as you commit there, your Argo CD will go ahead and update. Okay, so let's cross check and do that. So what we will do now, I need to create a job. So let's go back to our Jenkins. So you can already have a pipeline. So let's create a second pipeline. All right. And I'll give the same name here called Spring Boot, not this, your Spring Boot CD pipeline. So new item. And this is where your Jenkins file are helpful. But before going there, I just wanted to show one more thing. You see there are two parameters that I'm passing. One is the name of the tag and another one is a password. Why I'm giving it as a password here is because, well, I'm trying in my repo, but if you want to try in your repo, give your password. So that's the reason I've just added one more option. So in real time, you don't need a password because it will be only one user. But since you are also going to try, change this to your password and look here. Here I have given my URL. So instead of that, change this to your URL and what is the name of the repo where you have the code. All right. So these are the only changes that you should be doing for your tryout. So now come down, it's a new job. So I'll say Spring Boot CD pipeline. And once again, it's a pipeline. And again, where is the code? The code is in the new repo. So that's where we have two repo. One's for source code of your application or microservice, and we have a separate repo for our deployment. That is your Kubernetes YAML file. So come down here. So pipeline and SEM, git, and this is the name of the repo. Okay, and branch is main, and the name of the Jenkins file is same. Go ahead and save. However, well, for the first time, it might not show you the parameters. So in Jenkins, just do a dummy build once, and then the next time you will see, it will be asking you to enter two parameters. Okay, one is the password, another one is the tag, that is the image tag that you want to deploy. So I'll just show you. Let's run it once. I know it will fail now because we haven't given the password properly and it has not taken. So you refresh. So now you see build with parameters. Okay, I'll show you one test execution. So now in your Kubernetes YAML file, what is the image tag I have given? 50, which is the old one. Okay, now let's test and check whether the pipeline is working and your Argo CD is also working. That is, your CD pipeline is working. So now here I'll give my password. Okay, and let the image name be 1. So what this pipeline should do, update this YAML file. Okay, and however, since we are using a GitOps approach, as soon as the YAML file gets updated, you should see Argo CD should sync if you have given automatically. If not, it will say that your actual deployment is not sync, it needs update. Okay, so it says success. Let's cross check. Now if I refresh, what you should have here, 1. So this is success. And now let's come back to my app. Okay, it usually take a couple of seconds. So I'll just refresh this. I'm not doing anything. Okay, so you can just do a refresh. And since it is manual, it says out of sync. So you understand now, right? No user needs to run any kubectl, or you don't have to connect to the cluster. And you can cross check here by doing a diff. So there is only one YAML file which is modified. What is that? Your deployment YAML. And in that, what is the change? Scroll down. So it's saying you had 50, now you are having 1. So this way, whether if I'm a QA, I don't care whether I want to deploy the first image, last image, or anything I want. So use this pipeline, which gives the flexibility to deploy any image or redeploy. Correct? Clear so far? And now, again, if I just go ahead and just say sync, it will go ahead and recreate. And that's where, what does your deployment object do? It will create a second replica set. So now you see there are 2 replica sets, and in that, it's trying to create a new pod. Well, it's failing, not a problem. Why it is failing, if you can see. So you can, this is where you can see, you don't have to go to kubectl and run those commands. I can see all the events that is happening. So it says that there is what? It says permission denied, or do I have that image with tag 1? That's what is the question. Okay. So this is the repo, and I don't have a tag called 1. So that is why it is not downloading. So let's not worry about it. Okay. So far clear. So what we have achieved is a deployment pipeline, which gives you the flexibility to deploy to a cluster any image that you want, and you can deploy anytime. All right. So now let's combine everything and look at the end-to-end magic. So now I have a build pipeline, which is a CI pipeline, which will get triggered anytime when a commit happens. And now I have a deployment pipeline in which someone has to trigger, and you will tell a image, and that will deploy that. But what if I want to combine both of them to form your CI/CD? So what is that? So that means I have my deployment pipeline, and I also have my build pipeline. So my build pipeline will get triggered, which is the CI pipeline, which will get triggered whenever a commit happens in your source code repo. And all we have to do now is, at the end, add another stage wherein in Jenkins we have a concept called a downstream job. One job can call another job. So all we have to do now is, in your build pipeline or your CI pipeline, add a new stage, and in that call your CD pipeline job, and whatever the image that you're building, that latest image tag, you pass it. So that way what will happen? Now when a developer commits a code, a new build will be triggered and a new image will be generated, and that new tag will be passed to the CD pipeline, and CD pipeline will update the YAML file, and immediately it updates, your Argo CD will go ahead and do the deployment, and that's how your CI/CD will be. So it's not a single pipeline, but 2 pipeline connected using a concept called GitOps. So now let's do this whole, and this is exactly where I was referring to you, that in your build pipeline, I have one more YAML file, sorry, the Jenkins file. Okay. So now since we are doing the CI/CD, every build that I generate, I want to create a new image and push that into registry, and that should be the tag which we have to call and pass it to the downstream CD pipeline. Okay, so go to the build pipeline, and now here you see the second YAML, sorry, again, I keep missing it, the Jenkins file. So in this, now this is where I'm going to pass my password from here, because now understand who is going to call your CD, your build pipeline. In our case, I want to pass a password there, right? So I will pass it through my CI. So in reality, you don't need it. For practicing, you pass. So you pass your password to your CI pipeline, and CI pipeline will call CD pipeline and pass the password, as well as it will pass the build tag, and your deployment will trigger. Okay, and this is where you come down. All I have done is, when you are building a tag, I have just adding the name by saying the number. So if you're going to do a build 10, you will generate a Docker image of build 10 and you will push it, and the same build 10 will be deployed into Kubernetes. And that's where is my last stage called trigger deployment. And here I'm calling a build another job. And this is where we have installed a plugin called trigger with parameterized build. So here I'm telling call a pipeline called Spring Boot CD pipeline, and see what parameter I'm passing, the password parameter, and whatever the image name that you're taking. So instead of we going here and directly calling this, our pipeline will pass. That's all. So I don't want you to touch anything. So just go back to your build pipeline and come down. So instead of giving this as Jenkins file, now give the name of this file, which is Jenkinsfile -CICD. That's all. So that's where I want you to practice and get hands-on. All right? Done? So now, once again, it might not show you the options. So in case if it doesn't show you, just do a dummy build once and it will try to trigger. Okay. So let's just do a dummy build and cross check. So you can see it's not showing, but anyway. So what we expect here is every time you do a build, now build 4, so there should be an image tag called build 4, and that should be deployed to your where? To your Kubernetes. So that's when it becomes CI and CD. So you can see. Now let me stop it and show you so that the pipeline actually works properly. Okay, we aborted. So now, again, this is for practicing, right? So if not, you can go ahead and hard code the password. Well, I can show you that, but then I have to hard code my password. So instead of that, I'm just trying to give it manually. All right. So now all I have to do is give the password and trigger the pipeline. Assume the same thing will get triggered when a commit happens. That's all. All right. So here, all right. So now that's your CI pipeline getting triggered. Okay. So it will go through all the stages. And once it is done, now what is the build number that we see here? Build 5, right? So build 4 was the previous one. So now it should see build 5. So if everything is good, there should be a new Docker image called build 5 should be generated. And this YAML file should be updated with 5. So that is when it is a CI/CD. So let's cross check. It's running. Well, you can check for the stages. Okay. So build is done. Code coverage is done. SCA is done. And then it's going ahead with SAST. Once that is done, it goes to quality gates. Now, I forgot to show you in SonarQube. I'll show you. And then it's going with build image. Okay. And what should be the image it should be pushing? Build 5. All right. And once it is built, we scan and we do a smoke test. Well, that has been built. Cross check here. Okay, let's go to my Docker Hub account again. You see, build 5. All right, and come back. It's doing smoke test. In meantime, I'll also show you in SonarQube, which I forgot. So now you go to SonarQube. You have a project called WezvaTech where the quality gates is run. But look at here. So it's showing you all the results. It's showing you the code coverage. It's showing you if there is any third-party dependencies, that is SCA, as well as it is also showing you the SAST results. Okay, so that's how only when you install those dependency check plugin, you will be able to see everything. Okay, so this is one of the project where you have all of them and you can go through and cross check what's that and how it is working. Okay, so since everything was there, our quality standard was also within what we have given, so the code successfully passed. So that is how, if any one of these is not matching your profile in the standards, your quality gate will fail. Okay, so now just to come back here, it's still running the smoke test. So once the smoke test is run, it will go ahead and trigger your CD pipeline, right? So again, to show you that, so this is only 2 jobs, the execution. Now once this done, you should see the third execution, which is called from the parent, which is your build pipeline. Okay, it says error. Okay, let's check why. Not a problem. Have I given everything proper? The name is CD pipeline. Okay, name is good. Come down. Something is wrong. Okay, it says no such property called build number. Okay, let me quickly check where I have given this as build number. Okay, here it's not taking it up. Okay, let's try one small change and check whether it works. So it's taking everywhere properly. All right. So whereas here, tag, it's not taking up. What could be the reason? Okay. So let's say with quotes, and let me try if this works. Let's trigger it again. Okay, guess why the 6 is running? Because we did a commit there. Right, as soon as we did a commit, the webhook is triggering a job. Again, this will fail, so we'll stop this. Okay, let's see if this is going through. So for some reason, it's not recognizing, but let's check why. So I believe it's because of quotes, but let's cross check. SAST. Okay, build the image. And this time it should build and push image 7 because our build number is 7. All right. Okay, now again there's a problem. So looks like earlier it says your smoke run. Okay, there's a container which is already running. The state skipped in between. My bad. So let's quickly go here and build server and delete that container. Docker ps. Oh, sorry, which machine did we connect? This is build server, right? Then why is it coming here? Okay, Docker. No, it's coming to minikube. Did we install minikube? My bad. By any chance, did I do it on? Okay, let's check. That's where we name the service. Docker images. Okay, this is the proper one. So there is already there. So let's stop this. RM force. Okay, this should delete. Again, unfortunately, we have to run it from the beginning. Build 8. Anyway, you should be seeing now 7 is already pushed. Okay, you see 5, 6, 7. Anyway, let's wait. Okay, build image is going through. Okay, hope it won't fail. Oh, shit. Why is it failing again? My. Well, that's because it didn't. My bad. Okay, I'm sorry again. There's one last try. Let's go ahead and do this. But anyway, it's a good thing you see every time a build, you understand that a new tag is getting generated, and obviously that's what we want to deploy. At least your build pipeline is working. I should say, please complete this time. Okay, SAST. Quickly. There's nothing running, right? Okay. Okay, smokes test. Hope one more stage will go through. Well, that's what makes your DevOps interesting is you need to be good at debugging and you need to kind of make sure everything is intact. So it's not like you write dev pipeline and leave it, everything will work fine. Again, you have to write your automation in such a way you think about all the scenarios. Well, this is what you do in a day to day. You modify something, don't expect it'll immediately work. So that's where many times people think, oh, it's just that you sit and do one time and nothing else will be there. Like even anyone, right? You just modify, you do some small change, and you have to make sure you test it thoroughly. So that's where on a day to day, there's been a lot of operational work that you have to go through. Okay, so smoke test is running. I just want the last stage to get triggered. Okay, it triggered. Let's quickly cross check. There is that CD part triggered. Awesome. Now we'll just wait for this to complete. So now if you understand, your CI pipeline triggered, what is the build number? Build number 9, and it called CD job, and we passed two parameters, the password and the tag, which is build 9. And you should see it completed. So go to your Kubernetes YAML and you refresh. What is that you should see now? Build 9. And now, since it has updated, go back to your Argo CD. And again, if you have patience, wait for a few more seconds or just refresh. You should see it saying out of sync, which means it needs to do deploy. And that's where if you have made it as automatic option, it will deploy. But just to cross check, what is the change? Earlier it was 9, now it is 10. Okay, so if we go ahead and sync it up, so it will again create a new replica set. Okay, and this is the pod. Okay, no, why is it? Which one is the new one? Few seconds ago. Okay. Okay, so it says it doesn't know the repository. Well, let's not worry, but just to solve time being, I'll just do a Docker login there. It should work. Okay, but anyway, what we wanted is to see how Argo CD takes it up. So let's connect. Yeah, because it's just a small project. I haven't given the credentials here, but anyway, it should go through. So Docker login. Well, it should go ahead and do that. Okay, so when the next deployment happens, we should see it should be trying to recreate the pods. All right, so clear so far? So what is your actual CI/CD in real time? So this is how you're not going to have a single pipeline, because whether you're attending interview or even you're trying to set up your own project or you're going to a client interview, so try to understand on the modern DevSecOps method, your entire CI/CD is divided into two pipelines. One is the build, which you trigger on a need basis, and you have a separate deployment pipeline and use the GitOps approach, in which it gives you the ability to build and deploy so that you can just connect these two pipelines as downstream. And at the same time, having a separate GitOps approach of the pipeline gives you the ability to securely deploy, and you can also redeploy. And now I can just set up the same way another two apps so that I can choose to deploy to QA or to production. Okay. So again, as you see, this is one of the sample project. But again, for those who are looking out for a career change or looking out for a better career or a better salary in terms of your DevOps positions or cloud positions or SRE positions, that's when we highly recommend to go through our DevOps Ninjas program. And in fact, whatever you have seen now is one of the project that we actually doing it live in our DevOps Ninjas program. Okay, but apart from that, for those who are beginners, please subscribe to the channel and make sure you go through all the prerequisite videos like Linux, we have Git, and in fact, we have things like Docker and GitOps, so that get hands-on and understand the subject. And make sure you subscribe to the channel so that we have any future webinars will be alerted to you.